Hello, let's learn the Bash Unix style shell following the Bash tutorial from w3schools.com. This is the URL w3schools.com/bash/index.php. And let's start from the beginning. I am on a Linux operating system Ubuntu 25.10. I have a terminal emulator open, this console, on the left half of the screen. I'm already running the shell bash. And on the right half of the screen, I have the documentation, the tutorial. So it says that in the history of Unix, there used to be the sh shell, sh, Stephen Born. Then there was csh, ksh, ash, dash, and bash 1989 born again shell. And this is the one that we're talking about, the GNU bash shell. This was the default shell, or is the default shell on many Linux operating systems. It's available in Windows, in WSL, and in the Git bash. Is or was the default shell in macOS, Solaris, Open Solaris, and many other operating systems. You can use it to run it interactively. You run commands while the shell, the REPL, read, evaluate, print loop of bash is running. Or you can put bash commands in a plain text file with a shebang, and then you can execute that file. And bash will interpret each and every line in the file and execute the commands that exist on each line in the file. Let's see if bash is installed. This is the command that we're going to run. This is the standard output or standard error from this command, and this is called the prompt. In my case, the prompt looks like this: username at computer name colon pwd, and then the $sign to specify that I'm not the root user. And the prompt in these examples are similar. So square parentheses, username at computer name, and square parentheses, space, and then $sign to say that you're not the root user. Okay, so the standard output is from an older version of bash. I'm on version 5.2.37, and the tutorial has used bash 5.2.21. So at least a number of years older. Okay, and then to see if you understood the tutorial, which again I recommend that you follow along by having on the right half of your screen the tutorial. On the left you should have bash running in a REPL loop, and then all of the commands that you see in the tutorial you should either self-dictate, so just type on the keyboard, or you can copy paste. There's two ways of copy pasting in Linux. You can select and middle click paste. So click on the scroll wheel without turning the scroll wheel on your mouse. Or you can go Windows style copy paste, right click, copy, and then right click paste. Okay, and in this case with exercises, you should click on version and then submit answer. And the answer is correct. We're going to continue the tutorial, go to the next page. Of course, this tutorial doesn't really talk that much about bash, but it's most about the Unix userland, so the executables that exist in your path that you can run. Some of these might be from your operating system, so in my case from /usr/bin directory. Some might or not be shell built-ins, but the minimal Unix userland contains tools and executables such as ls, ps, cd, pwd, grep, awk, free, df, mount, etc. And we're going to learn both bash and some of these executables from the Unix userland. 1989 Brian Fox. As you can see, it's a GNU project from the Free Software Foundation. Next page. So we have already run bash -version, which means that bash is available on my system. If it's not available on your system or not installed out of the box on your system, on Linux operating systems, it's probably going to be available in the binary packages in the repositories of your Linux operating system, and then you can install it. On macOS, you probably can install it via Homebrew. On Windows, you can install WSL, which is actually the Ubuntu Linux operating system that will have bash pre-installed, or you can install Git for Windows, and Git contains two executables, git-cmd.exe and git-bash.exe. So you can start git-bash.exe and have a bash environment, but also some of the Unix userland executables. Okay, so we saw examples of running commands like this one, bash -version. The command is when you press enter, bash, which is the REPL, read, evaluate, print loop in this case, will read the command that I have entered, bash -version, will start a subprocess, bash with command line parameter -version, will connect standard input, standard output, standard error streams, such that you can see the text that's outputted via standard output by this subcommand will be shown in the REPL in here. So this is using bash interactively, but you can also use script files. Let's see how that works. So it says that we can create a file named hello.sh. Let's use, for instance, the text editor that doesn't have a graphical user interface, uses a text user interface called nano. Hello.sh. So the name of the executable, that's the text editor, nano, space, and then the file name that we want to create, hello.sh. Inside we want this content. Hopefully copy pasting works. So shebang, path /bin/bash, and then you can, starting from line 2 and then from then on, you can just place valid bash command lines. Such a valid command line in bash is echo followed by a string enclosed in double quotes. I have pressed Ctrl X, save modified buffers, suggests that I press Y, and then enter. Let's see the contents of the current directory, ls. So in the current directory, which is tilde, which means my home directory, there's a subdirectory work, and then there's a subdirectory 1, and I'm in there in tilde/work/1. in there's just one file, hello.sh, which was created by Nano, the text editor, that this file has the correct content, and hopefully we can run it using bash. So bash, and then the name of a plaintext file that contains the bash shebang, and then command lines, which are valid for bash, separated by new line, are going to be executed. Drag and drop the correct code to show which version of bash is installed. Next. Bash commands are how you interact with the operating system and perform tasks. So again, some of these are not bash built-ins, but really executables that exist in the environment where bash is running. So in the case of Git for Windows, there's an entire Unix userland provided with the installer of Git for Windows, such that common Unix executables do exist when you're running git bash, such as cd, ls, make dir, etc. ls, ln, rm. Okay. So do not say that ls is a bash command. ls is a Unix command that happens to exist in this environment. It comes from here, /usr /bin/ls. Okay. We can see on the right-hand side a list of commands which are used for what is called file management. So ls lists the files in the current directory or other directories. cd changes the current directory. pwd prints the full path of the current directory. echo will write text to standard output, so this is not really file management. Cat displays the content of a file. Copy makes copies of files and directories. Move moves or renames files or directories. rm deletes files or directories. Touch creates an empty file, or if the file already exists, updates its m time, its modified time. Make dir creates a directory. I'm not sure why people keep calling directories folders, but I'm going to call directories directories. cd is change directory, not change folder. It's the same thing, folder or directory, but I'm going to say directory. Okay, and then we have an incantation of file management. Let's actually do all of these. So make dir will create the directory that you give as parameter. My underscore directory. We can change there. I have pressed the tab key. There's no need to write the name of the file because there's just one file in the current directory. So by pressing tab, bash knows how to autocomplete. Okay. And then inside my directory, you create a file named myfile, an empty file with extension txt. We list the contents of this directory tilde/work/1/my underscore directory. There's just one file there. And then we are at the step where we learn about the ls command that lists the content of directories. And in here, in order for us to see similar output from our system, we will want to create a directory structure that's similar to this one. And I'm going to do just that. I'm going to show you how I have created this file structure. So I'm starting in directory ~work/1. There was this my directory that doesn't exist in the output, recursive output of ls-r, so in the current directory, which I need to delete, but it had content, so I needed to use the command line parameters -r-f for the rm command. Then there existed this hello.sh file that doesn't exist in the output of ls-r, uppercase R, so I needed to delete it. At that point, the directory 1 was empty. Next up, I created using touch these two files in here, and this file in here, and these two files in here. So as you can see, the touch command line will create files, and it can receive more than one file name via command line parameters. So you can say touch, then the name of one file, and then the name of another file separated with spaces. Then I needed this subdirectory images, make dir images. Then I have changed into the directory because I wanted to create these 4 files. cd images and then touch for files with extension png with names going from 1 to 4. And then I needed to go back to the directory 1, which is change directory to the parent directory. I need to have a directory named my folder, which I did. This my folder directory needed to have a subdirectory new directory and a file my_file.txt. So I need to change into this directory, my folder. Then I have created a file my_file.txt using touch. I have created the directory new directory. And then that's it, because the directory my folder new directory is empty. Let's see the output of ls-r and see if it's the same. So Ctrl L or clear clears the screen in bash. ls minus uppercase r. Okay, so it says like this. This colon means the contents, and to the left of the colon you have the directory. So in the directory dot, which means the current directory, there are the following files or directories: 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 2 directories, my folder and images. And then in the directory, current directory /images, there's 4 files. And then in the current directory /my folder, there's 1 file and 1 directory. And then in the directory the directory dot /my folder /new_ directory, there's nothing. So by using Unix style commands, I managed to create this exact same structure of directories and files. The files are empty. For instance, 4.png is not actually a picture, an image. As you would expect, it's just 0 bytes in there in the content of the file, because I have created a file using touch. And now we can start this tutorial page or the command ls from start. So ls lists the contents of the directory. If you don't specify any command line parameter, it will list non-recursively the current directory. You can see the relative path of the current directory, ~work/1. And you can get to the help of the ls command using the command line parameters --help. This will depend on your operating system. This --help is probably a GNU extension, might not exist in your operating system. Says it lists contents of directories and ignores files and directories starting with a dot, which means it will not show hidden directories. Unix-style hidden directories or files have the file name starting with a dot. So ls and then command line parameter would be the directory, for instance, that you want to list. But the directory to list command line parameter is optional. You can see optional command line parameters because they are enclosed in square brackets. As option, we will see immediately some command line options for ls, such as -l, which in this case, just ls will show just the name of the file or directory that's in the current directory, and then some white space, and then the name of another file. Whereas ls -l will show additional details such as the size of the files. Depending on your operating system, you might also have the manual pages installed. So man ls shows more information. If you cannot really read this information because it's too much, it's hard to search through, etc., there's possibilities of having the output of the help written into a text file, and then you can open that text file with a text editor. For instance, you can redirect the output of ls --help to a plain text file, which I put straight into my home directory. So tilde is the home directory, and in there I will create a file a.txt. And then I can open this with a text editor that I like. The text editor that you like, you should use at this point. Why is it advantageous to open a ton of text in a graphical user interface text editor? Because you can do things like searching in the way that you used to. So -l, let's see -a. I just find it way easier to read the output of --help or of manual pages inside a graphical user interface text editor. And then the same you can do for the output from manual pages. So we have the manual page, which uses a paginator, which might be pager, which might be more or less. The more or less being the name of the pager that you're inside right now. The one that allows me to press the down arrow key or up arrow key, page down, space to go page down, and Q to quit. Okay, but if the paginator is not, you don't know how to use the paginator as well as you know how to use the graphical user interface text editor of your choice, then do the same thing that I did, which is put the output of man in a plain text file and open it with your preferred text editor. Again, I find it way easier to search in here. So -a means -all. I want to search case sensitive. I can search by whole words. I can go search all. So -a is not a whole word. Okay. Yeah, I don't know. I can go really complicated by using, I don't know, regular expressions. Or I don't know how to use regular expressions. Okay, I have the minimap, all sorts of advantages if I use my preferred graphical user interface text editor. Okay, so just ls without any command line parameters shows just names of files and directories, nothing else, no other details. Whereas ls-l shows also the size in bytes of the files. So they're all empty, 0 bytes. Shows the Linux user that's owner of the file, shows the Linux user group that's the owner of the file, shows the M time or the C time, the creation time or the modification time, and Unix style chmod bits. Okay, so we already know how to run ls without any command line parameters. With -l command line parameter, there's -a to show hidden files. In the manual page, it said that it's not showing files or directories that have the name starting with dot, and -a will also show those, the files and directories with names starting with dot. H is human readable sizes, which will convert bytes into kilobytes, megabytes, gigabytes. Sort by modification time descending. Sort in reverse. Sort recursively. Sort by file size. ls lists just names of files and directories in the current directory without going recursive, but ls-1 will put each name on a different line. Okay, so let's see, ls-l, file permission chmod bits, number of links, I'm not sure what that thing is, owner name, n is actual the name of a Linux user. Okay, owner group, file size, this guy. For directories, it's not the actual size of the directory and recursively all of the files and directories inside of that directory. So this is M time, the modification time, file or directory names. Okay, and then I should create this secret file. Let's do that. And if I go ls, it doesn't show the hidden file because the name starts with a dot. But if I go ls-a, it will also show the hidden directories, the directories with names starting with dot. So dot, which means the current directory, dot dot, which means the parent directory, and the hidden file dot my underscore secret my underscore file. Human readable sizes. So they use L and H together. In this case, it has converted 4096 or 4096 bytes to exactly 4 kilobytes. Okay. Sorting by time most recently modified first. It's a nonsense to use -t without actually using L. So the files created at the minute 43 are newer than the files created at minute 42. You can reverse the sort order by putting an R to reverse. This reverses in this case by time. So the older is first. But you can also reverse by file name, which means the one starting with V is first and the one with an uppercase C is the last. When we're using bash, there's great chances that the file system that we're on is case sensitive, which means that if you have two files with the exact same name but different capitalization, that will be allowed. And the sorting will behave in maybe not the way you think it does. So I can go touch a.txt and touch uppercase a.txt and then ls. And there's two different files, uppercase a.txt and lowercase a.txt. Always pay attention of the casing of your file system. Is it case sensitive or not? Not case sensitive being MS-DOS, FAT16, FAT32, EXT-FAT, VFAT, Microsoft NTFS is probably mounted case insensitive. And then there's also offerings from macOS where the file system is case insensitive. I prefer case sensitive file systems. Let's actually remove these two things. So RM, A, and A. Control L to clean. And we also already saw ls minus uppercase R for recursive listing of the current directory and all of its subdirectories, and then recursively in the children directories. So it lists the directory of the contents of the current directory, finds all of the directories in the current directory, which is images and my folder, changes into the first one, images, and then lists directories recursively there. Then goes back to the current directory, changes into this directory, the second, the final one, my folder, and then lists recursively that directory. If you have programmed before and if you have used recursion before, everything will be easier to understand. Sort by size. Again, doesn't really make sense if you're not using L. It has put the directories first because they're 4 kilobytes and the rest of the files are 0 bytes in size. We already saw ls-1 to list only directories. Lists directories themselves rather than their contents. I'm not sure what this tries to mean. I don't know. 90% of what you saw here as command line parameters to ls, I have never used. So I have never used ls-d, ls-1, ls minus uppercase s, etc. but it's useful to know that they exist. So you should go from the state where you didn't really know that the ls command exists. You're going to the phase where you know that ls exists, and ls is capable of listing, sorting alphabetically, descending, ascending, sorting by time, by m time, by size, recursive, etc. But you're probably not going to remember all of the ls command line parameters, and that's okay. You should know that ls exists and it knows how to do a ton of things, and then whenever you actually need the perfect syntax, there it's easy to just search it online or in an LLM. Okay, append indicator. I'm not sure what that thing is. Let's check. If it's an executable, it will put an asterisk. If it's a directory, it will append a slash. Yeah, useful, useful. Okay, and the way you combine command line parameters to ls, you can go -l -a, which means list long, so list it like a table, and -a also show files that start with a dot. So you can use ls, which is the name of the command, and then the command line parameters separated by a space, or you can combine them. ls space -la. So this should have equivalent behavior and output to this. ls space -l space -a versus ls space -la. Okay. Provide a command line to list directory contents with detailed information. This is about showing as a table versus showing as a list of just file names. So long. Next. cd. cd is about the current directory. There are a number of command line executables, such as ls, that will try to determine the directory to list, or the directory where to perform its actions. So if you just go ls, it will find out the current directory, ~work/1, and list its content. If you're going to provide a optional path, so the name of the directory, it will prefer to list that directory. But if you don't provide a directory as a command line parameter to ls, the current directory will be used. So the current directory is really important. If you're going to create a file with touch, where will this file be created? In the current directory. If you're going to create a directory, where will this directory be created? In the current directory. ~work/1. And when working with current directories, you have hopefully your bash prompt showing you the current directory, but there's also the pair cd, with which changes directories, and then pwd, the command line that lists the full path to the current directory. So whenever you're not extremely sure where you are, in which directory you're currently, you should use pwd command. Okay, so it says that we should change to the one of the directory that exists there. Let's delete the directory A first. So there's a my folder, cd my folder. Now the current directory has changed. It's not tilde/work/1, it's tilde/work/1/my folder. The new current directory exists inside of the previous current directory. It's a child. My folder is a child of the directory 1. Okay. You can change to this directory. Doesn't really make sense to change to the current directory. It doesn't actually do anything. You can change to this directory, which is the parent directory. You can change to this directory, which is a subdirectory in the current directory. You can change to the home directory of the current user, which you can do by just using cd without any command line parameters. The default directory is the value of the home shell variable. When you go cd, change directory, you can specify the name of the directory, but this is optional. It's enclosed in square brackets. So it's valid to just use the command line cd without any other command line parameter. In that case, the default directory is the value of the home shell variable, which is your home directory. So cd will change to the home directory. We can actually inspect the value of the home environment variable, and it's what we expected, /home/n, which is the home directory of the current Linux user, which is actually named n. Another way to go to the home directory is cd and then tilde. Okay, you can go up one directory because you can see that such a thing exists. This is actually a valid directory name, so cd ... will go to the parent directory, which is the directory tilde/work/1. We already went to the home directory. Again, by using cd without any command line parameter, you go to the home directory. Using cd tilde goes to the home directory. Cd ... goes one directory up. Cd ... doesn't go anywhere, but it's a valid command line because dot is a valid directory. It's the relative path of the current directory. And you can go to the root directory. Again, this is a Linux operating system, Ubuntu 25.10. It has the directories that you would expect in the / in the root directory. So there's /etc, /usr, /tmp, etc. I have used cd minus a lot, so cd space and then a minus goes to the previous current directory. So the current directory is /, but the previous current directory is tilde/work/1. If I go cd space minus, it goes to the previous current directory, which is tilde/work/1. Okay, this one, cd space minus, switch to previous current directory. cd/, we did that. Okay, and then it says that you can chain commands together. So the Unix way is that you can do the following. You can do ls and have the standard output from ls shown in the bash REPL, or you can put the standard output of ls somewhere else. For instance, you can put it into a file. The way LSX when it writes to a REPL might be different to the way LSX when it writes to a non-interactive standard output. So in this case, ls is smart and knows that we're redirecting its standard output and behaves like the command line parameter -1 was provided. So this is actually listing file names, each file name on a line, whereas when ls knows that the standard output is connected to an interactive shell such as bash, and it's also seen by a real human via an interactive terminal emulator, it's going to do different things. It's going to put file names on a few lines, and it's also using color. Plaintext files use the white foreground color, and directories you are using bold fonts and a blue foreground color in this case. The coloring will be dependent on your terminal emulator and your theme that you have applied to your terminal emulator. So if directories are shown in blue, in my case, they might be shown in a different color in your case. Okay. What else you can do? You can redirect the standard output not to a file but to the standard input of another command. And you can run multiple command lines when you press the enter key. So you can go ls and then cat copy and then change directory to my folder. So I didn't press enter yet. Yet I have 3 valid bash command lines. So there's ls, this is also a valid bash command line, and this is also a valid bash command line. I have separated them with semicolon, and then when I press enter is the moment when bash can actually see what I did. Bash actually receives this list of characters, sees that there's this separated semicolon that's not escaped, so it splits the long command line into 3 different command lines, ls, cat, and cd, and runs them one by one. First runs ls, which is what you see here. Then it shows the content of this file, which is actually 0 bytes empty, nothing is shown. And then it changes directory to tilde/work/1/my folder. And we can see the result in the prompt, or we can use pwd. So chaining commands, Unix commands, is the bread and butter of the Unix userland and the Unix shells. In this example, it changes directory and then it also lists the content of the directory. Let's do something similar to what's being done in here. So cd tilde/work1 and then && ls. So again, you can write freely in a REPL whatever you want until the moment that you press the enter key on your keyboard. When the enter key is being pressed, the characters that you have visible in after the prompt will be shown, will be sent to bash. And bash will interpret them according to a large number of rules. One of these rules is that if there's an && and it's not escaped, And then the command line will be split. In this case, it's going to be split into these parts. There's two different command lines, will be executed one by one. The first one is executed here. We can see nothing. Yes, so it's executed here. The current directory just changes. And then the second command line is being executed, which is ls, which writes this part. The difference between semicolon and ampersand, they behave very similarly, but each of the bash command lines might succeed or fail. If ls fails, the cat command will be executed. If the cd command fails, the ls command will not be executed. Let's prove that theory. There's no directory ~work/2. So the command line cd space ~work/2 fails because the directory does not exist. And then, because ampersand is the separator between these two command lines, the rest of the command lines will not be executed because the previous command line has failed. Whereas if we're using semicolon, ls will be executed. So first, this command line is being executed. There's no directory ~work/2. We can see this standard error probably. And then even if this command has failed, the next commands will be executed because we're using the separated semicolon, not ampersand. So ls doesn't do what we wanted, which is list the content of the directory ~work/2 because that directory doesn't exist. It lists the content of a random directory. In this case, of a directory that we did not expect. In this case, the content of the current directory, which might be anything. In this case, it's ~work/1. Okay. And we're at exercises. What is the current command to switch to your home directory? cd without parameters or cd tilde? pwd is again the pair of cd. cd writes the current directory, pwd reads the current directory. Okay, it has some command line parameters, -l and -p, that I have never used. Something related to hard links, symbolic links. Do remember that this command line exists, parameters exist, -l, -p, to deal with logical current working directory and symbolic links, but we're not actually going to exercise. Knowing your current directory is really important. You should not really depend on your current directory when you're scripting. If you're running command lines in bash and they work correctly, a common step is to just copy those command lines, put them in a plain text file, append the shebang at the start of the file, and this is it. You have created a bash script file. But do be really, really careful, because you don't know who is going to execute that shell script. You don't know in which directory that shell script has been, I don't know, downloaded and run. So you should never depend on pwd, on the current directory, when you're writing a bash script. If you want to list the content of a directory, then you're going to use the cd command, but don't just put 0 parameters after it. Actually put as parameter the name of a directory, the directory that you actually want to list. And same for the rest. You can use full paths when creating files. Be very careful about pwd when you didn't start the list of bash command lines yourself, but you give command lines to somebody else, or you give a script, a bash script, to somebody else. Provide a command to print the current working directory, cpwd, submit answer. Next. Next up is the echo. Again, some of these commands that you're running right now might exist on your disk in /usr/bin, or they might be a bash built-in. It doesn't really matter. The command line parameters will be probably very similar. And the names of the commands and the command line parameters are governed by a standard that's called POSIX, and not only that standard. There's an entire family of standards that is about the fact that when you're inside a Unix shell, a number of command line commands should exist, and these commands should allow a number of parameters. And there's actually an application programming interface that specifies which characters you need to type on your keyboard when you're inside a Unix shell, and those command lines should work correctly across a variety of operating systems that these operating systems respect the POSIX family of standards to a certain degree. So there's IEE 1003, there's the single Unix specification SUS, IE standard 1003, different versions, POSIX 1, 1B, 1C, 2, etc. So let's see the command echo. You can go echo without any parameters. It will print a new line. You can go echo and then an integer. It's going to work. You can put any text you want. It's going to be shown at the standard output. That's the purpose of echo, to put characters in the standard output. You probably want to use double quotes, as in this example, echo message, echo hello world, and we're given a number of command line parameters in these tutorials, -n, -lowercase e, and -uppercase e. So when we're echoing, what is being sent to standard output is actually, in this case for echo hello world, the following characters are being sent to standard output by echo: HELLO, comma, space, etc. D, exclamation mark, and then the new line character \n, which is the ASCII character with integer 10. Okay, but you can suppress that behavior by using -n command line parameter to echo. you can see that after D and then the exclamation mark, there's no new line. So bash was forced to print the bash prompt immediately after the exclamation mark. In this example, we are being shown something similar to the Pascal write and write line. So write would be echo minus n, write line would be echo without any command line parameter except the string. So it does a write and writes this thing, and then it does a write line and writes this thing plus a new line character. Wow, something's really bad. Yeah, sometimes the terminal will show interesting output. The command lines will be run correctly, but then the presentation inside the terminal emulator will not be great. At that point, a good idea is to just refresh everything using either clear command or Control L and run the command line again. Escape backslash sequence escapes. So if you want to put a backslash t. Wow. The bash command line tries to cater to the simplest usages, which is for ls just ls without any command line parameter. For cd just cd with nothing else but a relative path to a directory where it should change. And that has made bash really human friendly because it's optimized for you using the most common commands and using your keyboard to enter the most common commands. But then more complicated commands that require, I know, expansion of environment variables, double quotes inside single quoted strings, escapes, tabulation, pagination, things like that. So advanced scenarios that people don't use 80% of the time require that you know the bash rules for parsing. So the way bash interprets single quotes, double quotes, backslashes, dollar signs, especially when you're enveloping one in another. When you have double quotes inside single quotes, inside, and then you have a dollar sign inside, etc. The rules are at least complicated. They require a ton of reading and retrying until you find a command line that actually works correctly if you need such advanced scenarios. Okay. In bash scripts, you might use echo for logging. So for saying we have entered this script, we have entered this sub-algorithm, we have exited this sub-algorithm, we are in this then block, we are in this else block of an alternative structure, we're at the 10th iteration inside this repetitive structure, or it's for giving instructions if the script is run in an interactive shell. If there's a human that's seeing the output of the script, you might, using echo, give instructions to the user. Please press the Y key on your keyboard and then press enter to continue. Provide a command to display the message hello world. That's echo. There's other Unix command lines to write text to standard output than echo. Echo is one of the simpler, and it's what we start with. Next up, cat shows the content of files. So we should have a file named myfile, and we do. And this file should have this content, and probably a new line terminator. And now if we use the command line cat, the usage that you're going to have for cat in 99% of cases is just cat space the name of a file. So it takes the bytes that exist as content in this file and places them on the standard output, sends them to the standard output. You can use it to concatenate files in the sense that maybe you have two different files and you want to see in standard output in bash the bytes that exist in the first and then immediately the bytes that exist in the second file. This allows for scenarios like if you have large files, for instance, if you have a 3 megabyte file, you can split that file in 1.40 megabytes, which means that 3 files will be created, and each of those files will fit in a floppy disk, the Microsoft DOS style type of floppy disks. And then the reverse would be using the cat command. You can reassemble the 3 files and generate back the larger file. Add numbers to each line. Add numbers only to lines with text. Remove extra empty lines. Show non-printing characters. Oh, sounds great. I have never used any of these command line parameters. I didn't even know that these command line parameters exist to cat, but now I know. Okay, with -b will not show the line 3, which is empty. Don't show the same line twice. Show non-printing characters. Concatenate 2 files, so cat, the name of the first file, space the name of the second file. And that will print to standard output the content of this file and then immediately the content of the second. Or in order not to put the bytes at the standard output, you can put the bytes in a larger file using standard output redirection, which is the greater than character. Using piping with the vertical bar, you can, for instance, search for lines that contain a substring. So this is the content of the file. We can, so cat just puts the bytes in the content to the standard output, and then we redirect the standard output towards the standard input of the command grep. And then using grep, we only want to display the lines that contains shell. So there's understanding shells uses uppercase S, and grep is case sensitive by default. So the first line has not been outputted, written to standard output by grep. But then the second one is a shell or lowercase. So this line contains the word shell, and therefore grep has written this line to standard output. And because the terminal is interactive, grep went color mode, and it's showing me the substring that matched in this line as red and bold. And there's another match in the line where it says shells. Again, it doesn't find uppercase S, uppercase H, E, L, L because grep is case insensitive. The command line parameter for grep to be case it's case sensitive. Grep is case sensitive by default. To be case insensitive is probably -I. And in that case, it has also caught the shell with an uppercase S and the shell with an uppercase S and an uppercase H. How to display the content? Cat. CP is a file management command line. It copies the file to a different file. The destination file might exist or might not exist. The contents of the file, the bytes in the contents of the file are being copied. The new file will have a different name, but then there's discussion of what about the other elements of a file, such as the C time creation time, M time modify time, A time access time, the Unix chmod bits, the Unix user, the Unix user group, the ACLs, etc., etc. If it's a hard link, if it's a symlink. So Control L, cp --help. --help doesn't use a paginator. Man pages do use a paginator, but then --help tends to be way shorter than man pages. For CP, the standard output of --help is 4 pages long, whereas the man page is probably at least 10 pages long. One, two, three, four. Just 4 pages. Very short manual page. GNU Core Utils. Okay, so let's see the example. In the current directory, we have a file copy of my file, and we have a myfile.txt. myfile.txt has content, and copy of myfile.txt doesn't have content. Let's try to just do what the tutorial does. and it overwrote the existing file. This way, the existing file, which is copy of myfile.txt, used to have 0 bytes previously as content, and now it has 206 bytes as file content. And you need to use the command line parameter -i in order to confirm. So let's see that. So CP has a destructive behavior by default. Will overwrite destination files, which is not something that I did not expect. The behavior that I would expect is asking, hey, the file already exists. Do you want to overwrite? Probably I need to press the Y key. Yeah. Unix commands try to not show much output. If the command was successful, it doesn't confirm that, hey, the file was overwritten correctly. Hey, the file wasn't overwritten because that's what you selected. So you need to actually see for yourself, test the previous content of the destination file, the post command content of the destination file, to see what actually happened. Copy only if the source is newer. Verbose mode. Okay. Overwrite, and it still doesn't say anything. Okay, so when you use the verbose command line parameter -v, if a copy occurs, you can see source, copy, and destination. Copy being -greater than. I didn't know that -v existed, and it's very, very useful. Copy only if the source is newer. With copy, you can copy just one file, but then you can copy entire directories recursively. You can copy with glob masks, so you can copy 10 files at a time. You can copy all of the files with a certain extension. So at least then the -u command would come in handy. For instance, you want to back up this directory ~work/1. Backup meaning we make an exact copy at the current timestamp, which is 1450 hours. But then after some time, you want to create another backup. So that will create the content of the current directory. You will want to copy it exactly as it is, but with the next timestamp, 1451 hours. And when you're backing up, you're creating multiple destination directories, or you're reusing the same destination directory. And between two timestamps, between 1450 and 1451 in this example, actually no files have changed. And -u helps you have the second and third and fourth backup really, really fast, because maybe no files have changed, no file is newer because the time, the modified timestamp of the file did not change. Or maybe just one file has been changed in this minute that passed between two consecutive backups, and then only the content of that file will be copied to the destination directory. Copy directories recursively. Whenever you're copying directories, 99% of cases you actually want to copy the entire directory, so recursive. So do remember, if you want to copy directories, you probably want cp -r, the -r recursive copy command line parameter. copy only newer -u. And then wildcards is about globs. So all files with extension txt, that's *.txt. How can CP be used to copy all JPEG files to the images directory? Like this. CP-R doesn't have a source. So the must-have command line parameters to CP are source and destination. CP is mandatory, source is mandatory, destination is mandatory. The other command line parameters are optional. So CP-R and then images is not a valid CP command line. Neither are, so the second, third, fourth are invalid command lines for the executable CP. Next up, MV. MV is very, very similar to CP. Knows how to copy so CP took a file and either overwrote the destination file or created a new file if the destination file does not exist. But then MV, probably after that this copy is being performed, the source file is being deleted. There's some talk about how atomic is MV. MV should be as atomic as possible in the sense that if you're copying a file, a source file to a destination file, and the copy is incomplete, maybe the copy is over a network and the network has disconnected, you're not actually losing data. It's just an incomplete copy. You should check the destination file after copying. Whereas MV can be destructive if you're moving a file across the network and the network fails and only half of the file has been put on the remote computer, but the file in the local computer has been deleted altogether. You just lost half of that file. So be careful with the atomicity of MV, but also of CP and of other commands that you use for file management. So again, when you move, make sure that the entire file moves in a single microsecond. For instance, just do a copy first and then check that the two files are perfectly identical using, for instance, an MD5 checksum, and only then delete the source file. Or maybe make a backup of the source file, copy the source file to the destination, and then delete the source file. In this way, you should have, in the worst case scenario, two files. You're going to have the backup and the correct file in the destination. If you're specifying as command line parameters of MV the source file and the source and the destination file, then you're actually renaming a file. If you're specifying a source file and a destination directory, it's going to move the file from one directory to another. So MV with two parameters, both file names, does rename. MV with two parameters, one a file name and the second a directory name, does a move. Ask before, only if newer, verbose. Similar command lines parameters as CB. env with wildcards, similar to CP. There's actually just two wildcards. There's asterisk, which means any character any number of times. And then there's question mark, which is any character but just once. Okay, and you use asterisk either to get all of the files with the same extension, or to get all of the files that have a certain word in the name, such as my. You can go my ls. So ls and then ls my asterisk. There's two things with names starting with my. There's a my underscore file.txt, and then there's a my folder, which is a directory. If you want also to get this one, which has my in the middle of the word, then you need to put an asterisk at the start. So asterisk at the start means 0 characters, and then my, and then any character any number of times, or any character any number of times, and then my. So asterisk can be nothing, or one character once, or any character any number of times. Now it has caught two files, copy of myfile.txt and myfile.txt, and the directory my folder. And it's not doing what I would expect, which is show the files and directories in the current directory that respect this glob. Instead, it's listing the files and directories. So for the file copy of myfile.txt, it's a file, so it doesn't contain any files inside. It's not a directory. There's nothing to display. For my file, there's nothing to display. But for my folder, because it's a directory, it lists non-recursively the content of that directory. Okay. We want to rename a file mv. rm will delete a file or a directory with -r. Ask before deleting -i, -v to be verbose, and there's also -f to force delete. If, for instance, -r doesn't work correctly, you're going to go -f. Okay, so there's my new file. Let's make this file touch ls and then rm So rm says that it doesn't require the name of a file or directory, which means, I don't know, it's going to try to delete the current directory if it's empty, probably. Who knows? By default, rm does not remove directories. Use recursive -r or -r. Okay, so let's see this. rm, make it verbose, and then the new file. Okay, and it confirms that it has removed the file. Second time if you run it, it writes probably to standard output that the file does not exist, so it cannot be deleted. Okay, so you don't need to use the -v verbose command line parameter to get this exact same text if you're deleting a file that does not exist. So we should have a directory named directory. If you want to remove the directory, in the help it just said that files that rm does not delete directories by default. It says is a directory. And we can specify minus minus recursive minus r, so minus or minus uppercase r to confirm that we actually want to delete recursively a directory. Files will be deleted by default without confirmation, probably, depending on how your bash shell is being configured. Maybe there's rm is actually an alias to rm-i. Bash has the command alias, which tells us that ls actually doesn't run what we want. So ls doesn't actually execute /usr/bin /ls, but instead it runs ls, which we don't know what it is. It might be /usr/bin/ls, might be a shell built-in, and then it has put these command line parameters automatically, space minus minus color equals auto. So it's probably invoking this command. So we have a file named file.txt. We can just remove it. -f forces deletion without any prompts. Okay, so sometimes -f is needed, maybe because rm is an alias, or maybe because, I know, the file is in use, but Unix doesn't really have the concept of files in use. Sometimes you just need to go -f. And then -i means show the confirmation. Let's actually test this. So we have a directory called images. We cannot delete it because it's a directory. We can remove it recursively, but let's also ask for confirmation. It says descend into directory images, and if we press enter or n and then enter, means no. So nothing happens. The directory images is still there. rm. Touch command creates files if they don't exist, or change the m time, modify time if the file does exist. By default, it modifies the m time, but you can also modify the a time, the access time, when it was last read. Or you can say that it was modified sometime in the past. -c does not create file if it does not exist. Okay, some file systems don't really have access times, or they're mounted with the no a time parameter. Let's actually see this updating. So we have the file, my file that was edited at 1438. And now I have call the command line touch and then the name of the file, my_file.txt. The m time, the modified time of the file is now 1552 hours instead of 1438. You can specify a timestamp. Again, 90% of these things I have never used. I have never used -a, -m, -t, -c. I have used touch only to create files, not to modify the m time of files. You can use globs, so asterisk.txt, to change the modified time of all of the files with extension .txt from the current directory. Create an empty file with touch. Make dir creates directories. Make dir new directory. I almost always use ls-l instead of ls. The most often used command line parameter is -p. I use it almost always. I don't see why you would create a directory without using the -p command line parameter. That allows you to do things like directory 1 that contains directory 2 that contains directory 3. So there's directory 1 that contains directory 2, and then directory 1, directory 2 contains directory 3, and then current directory, directory 1, directory 2, directory 3 doesn't contain anything. Verbose output. Be aware that this is text meant for human consumption. You don't really know the format of this text. You don't know in which language this text is outputted. Maybe this is the English version, but could be a Japanese version of this text created directory. So when you're using make dir -v in shell scripts, in bash scripts, think about not grepping after the standard output of this command, or how you do it because of internationalization and localization issues with different languages than English, and other operating systems and other implementations of make dir than GNU core utils. I'm not sure if the standard output of make dir -v is covered by the application programming interface in the POSIX standards. You could create a new directory with chmod value, or you could create a directory and then chmod the directory. Make dir projects. Manual pages might be available in your operating system or your environment where you're running bash, or might not. Why might the man page is missing? Maybe you're inside a container and then a Linux container and their space is really limited, or maybe you're in a Linux operating system that doesn't install man pages by default, or maybe you're in the distribution that contains bash and other Unix commands that you're running bash from doesn't ship man pages by default. You can also run bash from a number of sources that is not a straight operating system. It's just a distribution of bash and other Unix executables. For instance, for Windows, there's Cygwin, there's Kit for Windows. There might be distributions of programming languages, such as Raspberry Perl. There might be MinGW, MC64, etc. All sorts of distributions that come mostly as a directory. And in there, there's the usual directory structure that you know from Linux. There's a bin directory, a share directory, a include directory with thousands of files in there, in those directories. Okay, so man, let's see where this thing comes from. /usr/bin man. There's a manual about man. So man is documentation for executables, as we saw previously, so man space ls. But there's also for syscalls, which is the interface between the kernel mode and the user mode. Libraries in the sense of C programming language standard library. File formats. Not all operating systems or not all places where you can run bash have the same grouping of the man pages, with one being executables and two being system calls. Not all of these 9 groupings exist everywhere. So man, section, and page. Section being if you have 2 man pages with the exact same name, but there's one representing an executable from /usr/bin and the other representing, for instance, a syscall. Okay, so you can go man.7 to display the help for man, but from the section 7. Man.a probably shows all of the from all of the sections. And -k is for searching. And there's also a command line that's called apropos that's very, very similar, maybe identical to man space -k. Let's look at man -k print. Wow. So there's a printf executable, but then there's also a printf function call. Format is the mandatory parameter. It's using probably a domain-specific language, format and arguments, similar to the C programming language probably. I don't really know how to use it because I have no examples. Let's see in the man page, printf.1. Is there an example in here? So the print format between single quotes and then the parameter. Like this. So it's just one argument. This is the format string. This is taking an integer from the list of arguments parameters. So percent and then I. And then these are the format specifiers with 4 and minimum 3 digits. Okay, so there's man for many commands. We looked at the man for ls, rm, make dir. You can search using the slash character. Let's search for dot dot. I'm not sure what happened. Dot dot means any character, right? It's a regular expression search. E. It marks all of the places where it found the letter A lowercase or uppercase. And then with N, we go to the next result. We're inside the paginator, probably less, so we can exit here with using Q. Okay, we can look at the man page of man, Q. We can search. It shows all the man pages that contain the string man in the description, so manage, memory management. The same thing with man minus K. Commands sometimes have a command line parameter named minus minus help. Okay, no need to exit because when you use minus minus help, it doesn't use any paginator. It just dumps the help string to the standard output, so to the bash terminal. Man ls, man grep. Again, if the text is way too long for your taste, you can always redirect to a plain text file and then use your favorite text editor. Apropos. Find all 9 matches. And minus minus help often doesn't have command line examples, whereas man pages often do have command line examples. The command line examples are usually at the end of the man page. Very important, the command line examples with valid command lines. As we saw previously, when we run ls inside bash, we're not actually running /usr/bin/ls, but then bash in our behalf runs ls space --color equal auto, because bash has a database of aliases. When you use egrep, it actually runs this command. When you use grep, it actually enables coloring. LL is alias for list, all, long, and I'm not sure what F does. So there's a database that you can look at using just the command line alias without any command line parameters. Or you can run command lines like this, such that you can invent new commands or overwrite existing commands. So you can change, for instance, LL instead of being ls space -al uppercase F to be ls -LE. And now this value is different from this value. Okay, I have never used aliases. I hope to never need to do this such a thing. Whenever you're exiting bash, your aliases that you have defined interactively using command lines like this will get lost. So it's important to have your aliases defined in bash script files that are being executed when you start bash. There are a number of bash script files that are being executed when you start a bash interactive session. Such as ~/.bashrc. In here, some aliases are being defined. Let's actually look at this command, at this file using a graphical user interface text editor. We have syntax highlighting. It's a bash valid script file, but it's a special file, ~/.bashrc. It's being executed by bash for non-login shells. Not really, it's executed for any shell, but if the shell is interactive, it doesn't do anything. So if you put command lines in here, it will be executed whenever bash starts, even if bash was started by, I don't know, a shell, a terminal that doesn't have interaction with the user, such as a hidden daemon systemd service. But if you want to be this file to be executed just when you're not running bash interactively, then you should put your customizations after line 9. Because if the shell is interactive, the execution of the ~/.bashrc file ends here on line 8, where it does return. /usr/bin/dir colors. Okay. You can read the database of aliases using just alias. You can write to the database of aliases using alias space and then some key pair value, key equals a value, key value pair. You can remove from the database altogether using an alias. You should use bashrc or bash_profile or ~/.profile if ~/.bash_profile doesn't exist. If you want to put these configurations per user, or maybe you want to create aliases for all of the users on the computer, and then you should use different files. So you can edit the configuration file ~/.bashrc, and at the very end of the file add something like this and save the file. And then restart bash. For instance, you can close the terminal and open it again. Listing files with detailed information. grep receives bytes through the standard input stream, splits those as lines using the new line terminator \n, and then as lines come into grep via standard input, if one line matches a regular expression, it's going to be written to the standard output, otherwise not. If you don't want to use standard input for grep, there's a command line parameter that provides the file that should be used instead of the standard input. So a file that contains text with new lines. Let's go back to where we were. There should be a file named file.txt. Understanding shells, a shell is a text base, okay. So grep, what, where, my_file. grep and then patterns, and then the file is optional. If you're not specifying the file, then the lines are being taken from the standard input stream of grep. And then there's a -e or -E for extended regular expressions. There's also basic regular expressions, or you might not provide regular expressions at all as the pattern. But most of the time, probably you're not specifying -E, -F, or -G, and you just provide a substring. And there's also PCRE, Perl compatible regular expressions. So 3 formats for regular expressions, or just substrings, no regular expression at all. Okay, that's the usage that you're using grep for the most, but this actually does require that you start learning the regular expressions. Regular expression is a domain-specific language that's extremely important if you're a programmer or if you're a sysadmin, or all of the other jobs that are in this area, such as, I know, DevOps, SRE, etc. Security researcher, Red Hat, Black Hat, penetration tester, IT department support. This is the place that you should be. The Wikipedia page for regular expressions, you should read it a number of times. I can say some words about regular expressions. It depends exactly what syntax for regular expressions you use, if it's PCRE, if it's .NET, if it's grep array, whatever. The syntax might be a bit different, but the in broad lines, what you have is like this. So if you want to match just a character, let's see if things work out with grep. If you want to search for just one character, such as the character S, you use that character. If you want to specify any white space character, I'm not sure what the syntax is in grep. Minus uppercase P. You use \s, / is special, it escapes, \s might mean any character that's like white space, such as tabs or spaces. Then if you want just once a character between S and T, you can go S, T. If you want twice, so two characters, you can go like this. If you want lowercase st, but also uppercase st, you go like this. So this would be a set, and on the first, you're searching for two characters. The first character is this set, and the second character is this set. So on the first position, the first character should be lowercase s, lowercase t, uppercase s, uppercase t. On the second position, the second character, they should be lowercase s, lowercase t, uppercase s, uppercase t. Then you can say one character out of these four, but at least once. You can say one character out of this set, but any number of times, including 0. No, this doesn't really work. Then you can say, I want just one character, but not S. You could use something like this. So a set that contains all of the characters excluding lowercase s and uppercase s. So with that, you can match any character because it's either a white space, or it's a to z lowercase, or it's a to z uppercase. You know how to work with sets, you can negate sets, so you can catch one character. You know how to reuse that character multiple times using plus or asterisk. You can catch any character, which is just dot. Dot is very special, means any character once. If you want to just catch full stops, dots, you need to escape it with a backslash. So backslash dot once. Backslash dot any number of times. Any character any number of times. And then just two things remain. The or, the subgroups, and the how many times. And then do learn this table by heart. Matches the preceding element at least m and not more than n times. Let's see how that works. I want to catch all of the vowels. At exactly 2 times. At least 2 times, but at maximum 4 times. Okay, and then there's the special characters, the start and end. So start is this thing, this line, and end is this thing. So we want all lines that start with a vowel. Like this. This is in broad lines 99% of what people use regular expressions for, at least when they're casually, really fast, creating a small regular expression for ad hoc usage, such as when using interactive command line shells such as bash. Okay. If you don't want to specify case insensitive, you can use the case insensitive command line parameter -i. And you can also negate, which means show all the files that do not match, all of the lines that do not match. So there's 3 lines that match and 2 lines that don't match. The -v reverses the pattern, the search. Okay, very important is this one, search through all the files in a directory or its subdirectories. How you use it is either you're using a command line for searching, such as dir space -r or find, and then having grep run on all of the found files, or you're using grep to navigate through the file system using -r, for instance. Recursive search. You give it a directory and say go recursive. And it returns the same thing, which is all of the lines that match, but it also tells you from which file. We did invert. We used regular expressions. Write the command to search for the term error in the file log. So error comes first and then the file name. awk is a programming language, domain-specific language, and a command line executable, AWK. You can go Ctrl-C to not execute a command. You wrote some command and just don't want to execute it. You can go Ctrl-C. The command line will not be executed. Ctrl-L to clear. Which AWK. Let's see what this AWK actually is. It's the alternatives mechanism in the Debian Linux operating systems family. Let's see what that is. It's actually GOK, which is GNU awk, or the executables that respect the application programming interface from the POSIX family of standards. There are many multiple implementations. So for instance, for awk, awk is standardized in the POSIX standards. It's available from the GNU project, but also available from the from some BSD operating systems. It's available in a totally different form, probably from BusyBox and similar projects. Some of these implementations are extremely bare bones because they must have a really small executable, such as in the case of BusyBox, a single really small executable acts both as awk, as shell, the entire sh, as all of the ls, cd, pwd, you name, and as hundreds of executables from the minimal Unix userland, which are defined in the POSIX standards. Okay, so we can go awk ---- help. Says gnu.org, gawk. You must specify, I'm not sure what. Program and file. So at a minimum you have program and file. Okay, let's see what the tutorial says about awk. Maybe you have a CSV comma separated values file. Let's look at this file. And must be named like this. Let's make sure we have just one trailing new line. Control X to exit, save modified buffer Y, press enter. And now we want to run a program, which is this guy, on the file. Let's see without any program if this thing works. No, because it tries to interpret the first parameter as a program in the programming language AWK. Okay, let's give it a program then, between simple quotes. The programming language resembles the C family of programming languages, so uses curly brackets. Print $1 resembles PHP and Perl with the $. But it so how it works, for instance, on this table of data, it tries to find $1, which means column 1. Column 1, this guy, is actually column 0. But for that, it knows it should know how to split a line into cells. So for that, we need to tell it that the separator is not space as usual, but it's actually comma. So you can see now in here that it thinks that the first column ends with John and the second column is Doe. Because by default the separator is space or white space. In this case, on the first row, there's no white space, so the entire row is the first cell, the first column. On the second row, there's a white space, so this is cell 1, column 1, and cell 2, column 2. Space, cell 1, column 1, cell 2, column 2, space, etc. So the column 2 is Doe, Smith, Davis, Brown, and nothing for the first row, which is exactly what you see here. And then the rest is column 1. That's why we use -f to specify the separator. So -f, and then comma instead of space. This way it takes the first line, finds the first separator, which is this character on third position, the comma. ID is put in the first cell in the first column, and then we should print the first column. So set the separator for data cells. You can put the program straight in the command line, or you can put it in a separate file. Okay, interesting how it does printfs using a variable that is defined at the command line. And then it's put in here. Okay, it knows how to read tables, cells, rows, columns, but it also knows how to do for each on those rows, on those cells. For instance, to compute a sum. This computes, and thus when the program ends, displays to standard output just one thing, which is the sum. AWK is very advanced. When you're starting to learn Bash, you're not actually learning AWK. You should not. It's an advanced scenario, but you should know that AWK exists in if you're connected remotely over SSH, if you're in a Linux container, in a strange virtual machine, in an embedded system, etc., if some of the executables from the POSIX standards are available there, and especially BusyBox, then you might also have AWK, and maybe you need to come up with a short command line that computes a sum of cells, and AWK comes in handy. You should know that this possibility exists for awk, and that awk exists. And then from there on, you will manage. You will try to find out if awk is really available there, and if it's available, find out what type of awk is, and then search on the internet and find a program that computes what you actually want. If awk is not enough for your needs, maybe there's Perl available there. Come search for a very simple program that does what you want on the internet and see if it works for you. Maybe Bash is enough, because Bash can also compute, can also do repetitive structures. if not, I don't know, maybe a C compiler is available, maybe Python is available. Do see what's available on your system and try to use the tool that makes sense and that you already know how to use, or maybe you can easily find help online. What is the correct command to print the second column? The indexes are wrong, so second column is $2, not $0. So submit answer. Probably $0 is special, is, I don't know, entire row or something. Set another command line from the POSIX standards. You usually use it to modify files. For instance, you have a file with many uppercase A's and you want to create another file that has the exact same content as the previous file, but all of the uppercase A's are now lowercase A's. The syntax is this guy. S all new, and if you want to replace once or everywhere. So we need a file named example text.txt. I'm going to use a different text editor than Nano. For instance, you can go Emacs. You can paste. Make sure we have a trailing line. Ctrl X S to save. Ctrl X C to close. Okay, let's see what's inside. Let's use sed. So they want to replace hello world with hello bash, but just once. Let's see if this is valid. Yes, it is. So a sed with no program just outputs the content of the file. Sed by default writes to the standard output. Editing the file in place would be destructive. So we want to S, which is replace, and then what with what? We want world with bash. World bash. Says that S is not terminated, so there should be a trailing slash here. So instead of hello world, it's now hello bash, and the rest of the lines stay unchanged. This is the command line parameter that is used, 80 times of the times that you use sed, which is you want to destructively edit the file that you have as command line parameter. Instead of writing the new content to the standard output, you want the entry input file to be changed in place. Extended regular expressions, which is ERE. Okay, and then the second thing is with G. You're probably always using G. To replace everywhere. -n shows only the change lines, probably. Let's see if that's the case. Nope. So presses automatic printing of pattern space. Set prints each line of input to the output with the P command. Okay, so if you want to see just the lines that will be changed, or you can use something like diff, a difference viewer, to see the old file and the new file. That would be something like, so we want to replace in the old file so we have the old file example _txt where it says world. We want a new file where it says bash, and then we want to compare the changes between these two files. Something like this. It says that a new file has been created, which is called example text _bash.txt, that contains this content. The original file has remained unchanged. Example _text.txt has this content. And then we're using the command line executable diff with two command line parameters, which are files from the current directory. Takes these two files and only shows the lines that have changed. Says that line 1, column 1 has changed from hello world to hello bash. The comparison in diff is line by line, not cell by cell. It doesn't say that only the word bash has been changed, but says that the entire line hello world has been changed to hello bash. Or you can use a visual difference viewer, graphical user interface difference viewer, such as meld. That is a bit more readable. Says that there's 3 lines in the before text, 3 lines in the after text, and the only thing that really changed is this thing that's shown highlighted. World became bash. Let's see a bit also /G. Alt backspace deletes a entire word with inside GNU bash that probably respects GNU readline, which by default provides a number of keyboard shortcuts for when you're writing text inside the bash terminal. So when you're writing a command line, you can use some keyboard combinations that are part of the GNU readline library and are similar to GNU Emacs text user interface text editor. Okay, so let's see. We want to replace the word line with hello. Let's see how that works. It replaced everywhere. Okay. That's interesting because I thought we need a G at the end. Okay, and the said program is a DSL domain-specific language, is a SED programming language, and the program can be part of the SED command line or be put in a file, and then you're using a command line parameter like this, says take the SED program, not from the command line, but from the file script.sed. And the content of script.sed is just plain text file containing the SED program. Long line splitting. We can redirect to a file, which we did here. This way you leave the original file intact, but you're creating a new file with the output of SED. In this case, with hello bash instead of hello world on the first line. Okay. Advanced text processing tasks. So S means replace, then start with the start of the line. Wow. So there's multiple. Yes, it's simple. It says find the start of the line. Each line has a start. And replace that thing with the string uppercase P, lowercase refix, colon, and then space. So what you expected happened. Common errors and troubleshooting. Okay, let's see what it says. Drag and drop the correct option to replace all occurrences. In my case, without /g, it did work. But it will say that you need G. Next. Cut. Okay, so very similar to what we saw with tables and awk, rows, columns, cells. There's the cut command. Okay, I'm not sure which is the separator here, space or comma. Control XS, Control XC. Cut minus F file name. And by default, it uses spaces as the field separator, similar to awk. Uses tab as the delimiter. Wow. Let's actually see all of the possibilities with cut. So cut, that was column 1, column 2, column 3. So yes, probably this is not just a simple space. So the character with ANSI 20, but it's probably a tab, which is, I don't know, \T7 or what is that? Okay, so we can specify a different separator. We want the second but separator to be comma. Okay, Show all fields except the selected ones. The order of command line parameters is so between -d, -f, and -minus complement, you can rotate them as you want. I'm not sure if you can have -minus complement after the name of the file. We'll see just in a second. Yeah, it does work. So be a bit careful with the order of command line parameters. Sometimes the text file in this case just must be the final argument in the command line. Other times the executable knows what you actually mean, and it allows you to do things like this, to have some arguments and then the file name and then other arguments. We did specify a delimiter which is comma. We did specify fields. You can show more than one field, 1 minus 2. We did use complement. I have never used cut in my life. Okay, let's see what it says. Drag and drop the correct option to extract the third field from each line of data.txt if the separator is space. Use the sort command, does what we expect. So let's create a file. I'm not sure why tutorials don't start like this. Before basic usage, they should say, please create a file fruits.txt with the following content. Okay, so we should create this file with content like this. Okay, and I do not know how to cut and paste. Control K and paste here, Control U. Cut here, Control K and paste here, Control U. Make sure we have just one new line terminator. Control X, Y, enter. And then cat. The order is not alphabetic. So let's sort them, sort the lines in the file alphabetically. Reverse order. Sort numbers correctly. Okay, we did in reverse order. Specify a delimiter for fields. Since when does sort know about fields? So sort knows about fields. The default field separator is white space. Sort by the second column. Minus K2, comma 2. What is that? Okay, let's see that. So sort, the delimiter really is a comma, so minus T comma and minus K2. 1, 2, 23, 3, 4. It works, but it doesn't use the correct integer sorting. Because after 2 there was 20. This is a string sorting, whereas after 2 comes 3 and after 4 comes 20 is numeric sorting. Cool. I didn't know that sort can sort by anything else than by lines. Remove duplicate lines. Okay. And we should remove keywis 3. Great. Complex sorting. Sort by the first column, then by the second in reverse order. Oh. Okay, it's interesting to know that we have such a facility in the sort executable. Exercise, sort the file, file.txt.file, sort, submit, next, tail. So tail, you use it 99% of times for following a file that changes, such as a log file. Lines keep getting appended to that file. Or maybe you want to only display the first 3 lines of a file or the last 3 lines of a file. Tail option file, let's see that. So by default prints the last 10 lines of files. And I'm not sure why file is optional. Oh, because tail knows how to work on standard input. Cool. And tail acts as cat if there's less than 10 lines. Okay. So we should have a really long file. How do we do that? With bash scripting. I searched for bash for each 1 to 100, and there's multiple ways to do it. You can do it with a for, or you can do it with a for with seq. seq is also an executable from the Unix userland. Probably also part of the POSIX standards. Let's see how we can do this from the command line. Probably we can. So for I in sequence 1 to 100, do echo line $I, and then done. Okay, that works. And then we want the variable I to be expanded to its value. Okay. lowercase, and all of this thing needs to go to the file named logfile.txt. And then we cut the thing. And it looks as we expect. We can also use less. So less is the paginator, is a read-only text editor. So it allows you to read the contents of a file. You cannot change the contents of a file. You use it either like this, less space the name of the file, or you could use this indirect way where the paginator can receive the text via standard input, and via standard input we put the body of the file using cat. Okay, so we have created this file correctly, and now we're going to use tail and decide that tails only shows the last 10 lines by default, as it says in the help. In here says print the last 10 lines of each file to standard output if you provide multiple files as command line parameters. The only command lines that I have seen parameters for tail is -n to specify a different number than 10 and -f to follow a log file as it grows. Okay. So let's see just the last sum. -n or minus lines. 20. And -f to follow. Let's actually see that too. So tail is an executable, is being started, looks at its command line. The command line parameters are -f log file name, logfile.txt, opens the file logfile.txt, reads its entire content, and does what it should do, which is print the last 10 lines. But then it continues watching the file logfile.txt. I'm not sure exactly how, using polling, so it opens it from time to time, or if it uses a notification mechanism each time the file is changed, tail is being notified, and it will look at the differences, so what lines are being added past line 100, and it will display the 10 freshest lines from the last print, the last time that tail printed something. So let's see how we do that. We'll have a second terminal where we add lines to the file logfile.txt. So echo what? And we're using append, not rewrite. So greater than will replace the entire content of the file logfile.txt. Greater than doesn't do rewrite, does append, will write the standard output of this command at the very end of the file logfile.txt. Now the last two lines in the file are line 100, then a new line character, then new space line, then a new line character. You can write anything you want to the new file. And probably to exit, Q. Nope, Control C. This is the most common way from the console to follow a log file, such as dmessage or some other file. For instance, the logs from a HTTPS server. Okay, we have displayed the last lines, but you can display the last bytes. You should need to know how files are encoded, how the content of a file exists, either as bytes but also as UTF-8 characters. Okay, interesting thing. So if you know that a process ID is writing to a certain file, you can make tail -f automatically close itself. You don't have to press Ctrl C when that process ID finishes. Yeah, --retry is useful because it's customary. It's often done that when you're writing lines to a log file, it will reach a certain size, for instance, 5 megabytes. At that point, the logger, the software that actually writes to the log file, will see that the file is larger than what's configured, will do a log rotation, so probably it will copy the file log file, it will move the file log file.txt, whatever rename it, put a .bak0 at the end for extension, or it might compress it using gzip, and then the original file logfile.txt disappears until the process that writes to the log file will write the next log line. That's how log rotation usually is implemented. And for a while, the file logfile.txt might not exist. So it might exist, then as for a millisecond while the log rotation happens, the file will move and will stop existing, and then it will be recreated from scratch the next time when a line is added to the logfile.txt file. So that's the --retry command line parameter for tail for that. Display the last 10 lines, that's the default option. -n. 10 lines, not characters. Okay, next up, head. Head is the equivalent of tail, and probably they know how to do each other's work. So head only shows the first 10 lines in a file by default. You can show the first 100 bytes in a file. And you probably can also do the same thing with tail. So let's see that tail -n -10 log file. Yeah, I thought such a trick works. With multiple files, you just provide more parameters, command line parameters. -q to not say from which file we're printing. I'm not sure why you would do that. So head is, I usually don't use head because I use bless. It shows me the start of the file, the first page, and then I just press Q. I don't really need head to see how the file starts. Head is more for non-interactive usage for scripting. First 100 lines. PS shows the processes. I never use anything else but PS AUX, and this thing works on all of the operating systems that I have ever encountered. All of the programming, all of the operating systems that respect the POSIX standard at least a bit. So not on Windows, but on others. And again, it's not just about operating system, it's about distributions of PS. So it might also work on Windows if you have a executable named PS that actually respects the POSIX API standards. PS AUX. Yes, the output is not great because it's truncated. I don't see full command lines sometimes, but the columns are the ones that I want. So username, process ID, if possible, the full command line. For more complicated things, like for looking at the memory, I'm probably using top. Okay. Understanding the output PID, process ID, you can, from an executable that, for instance, exists in /usr/bin, you can start it multiple times, such as the executable nano. You can run it 10 times to edit 10 different files, and that would create 10 processes out of a single executable. With each process has its own process ID, which is an integer number. Okay, CMD, the command line. PS, I'm not exactly sure what it shows by default, a very short line, a very short list of processes, which is, I don't know, the tree of processes of the parent process or something. But who needs this? I always need the fullest possible list of processes running on this computer. So X, show processes without a terminal. A, show processes with a terminal. U, show processes for a specific user. I'm not sure what this thing is, and I'm not using minus. So notice that I'm not using PS minus AUX. Instead, I'm using PS AUX without a minus. It's just a habit. I'm not exactly sure what A stands for, what U stands for, what X stands for. It's always when I use PS, it's the only command line parameter possible is AUX. Show all processes. Who knows? All processes and then detailed. Okay, so top shows the processes that consume the most CPU. That's the default sorting descending by percentage CPU. The concept of percentage CPU is important. The concept of percent mem is important. The concept of percentage NVMe or SSD or hard disk is also important. You need to consider that modern computers have more than one CPU thread though. So if it says 50% CPU, that might be just from one CPU thread, and I have 16 on this computer, so it's not as bad as it sounds. Hopefully it's not consuming 100% from 8 CPU threads at the same time and just 8 CPU threads stay idle. I'm talking about the OBS recording studio process. Okay, and then in here you also have additional information that you might be using other commands to fetch those, such as the swap state, which in my case I always use the command line free to see if there's any process using swap memory. So the fact that almost 10 gigabytes out of 32 are free tells me that I'm running 0 virtual machines. The fact that I don't have swap usage is good. Swap should always exist in emergency situations, but then there's 32 gigabytes of random access memory. There's plenty room for everything, for disk caches, but also for all of the processes that are currently running. Process ID, username, computing the total random access memory usage of a process is an art. I'm not sure if anyone knows how to compute correctly which process usage which part of the memory, because there's multiple processes using the exact same chunk of random access memory. You can say how much of the random access memory is free, but that's also an art, because the operating system tries to be as aggressive as possible, use almost all of the random access memory, which is a hardware resource, for speeding up the disk operations. So yes, I have NVMe storage, that's very fast, but then if there's a ton of random access memory that's not used, the Linux kernel will use it for disk, for caching and making file access faster. I'm not sure if top is part of the POSIX standards. Okay, you can look at just one process ID. And as you see, it's text user interface because it refreshes the UI. So this application is taking over control from Bash. It uses the entire screen, the entire terminal. It's going to refresh each, I don't know, second by actually destroying all of the text that's displayed in the terminal emulator and putting new values in each of the cells in here. So it can put text of different colors, it can put bold text, it can put text with different background colors. This is how a text user interface looks like. Text user interface application. So, and other examples would be the most text user interface editors, such as Nano. Also, Nano uses the entire screen and refreshes as needed. As I move the cursor around, the parts that are damaged are going to be refreshed. When I go Ctrl X, it will return to Bash. The other text editor is also a text user interface application. Also uses the entire screen, has help at the bottom, has a status bar. While I'm moving the cursor around, this line will show line 4, and now it will show line 3, L3, this guy. There's cursor selection, Control X, Control C. The tasks of the user. Okay, I'm not sure why you would use top in batch mode. So again, 99% of what I see here, everything from what I see here, I have never used. I have always just called top with no command line parameters. Okay. Top, bottom. Well, there's actually somebody made an executable named bottom that does exactly what top does, but with more bells and whistles. Okay. And then there's the commands in the area around mounted partitions. There's df. The most important command line parameter is h, which instead of showing bytes will show sizes in human readable format, in gigabytes, in kilobytes, megabytes. Okay, there's mount. When you use mount, you probably want to grep by /dev. There's du. -h. I'm not sure what the numbers represent, because images contains just 4 empty files, and it says that it uses 4,000 bytes, 4 kilobytes. Okay, so in Linux and in Unix and in other operating systems that respect the POSIX standards, there's a top level directory which is called slash, to which you can add additional directories in an operation that's called mounting. For instance, slash is actually a partition on my NVMe, the second partition, of type ext4. It's read-write, but then on slash there's all sorts of things mounted. For instance, in the directory /dev, there's this thing mounted. In /dev/pts, there's this thing mounted. And in /boot/efi, there's mounted the first partition on my NVMe storage. Okay. The name of the file system. df, let's see what df, and there's lsblk. Says the name of the device and the mount point. So slash is the second partition, P2, and /boot/efi is the first partition, P1. Okay. File system is either a kernel resource or a file from /dev. mounted on is under which directory this thing adds files and directories. But everything ultimately ends with the slash directory or starts from the slash directory. Okay. Human readable size is -h. Show the type of the file system. Cool. One ext4 and one vfat. Show empty ones. NSFS. Wow, what is that? Bin format MISC. Wow. So this -a command line parameter is an eye opener. I have not used it before. inode usage. POSIX output. Okay, and then some executables, some of the executables that we have run until now, such as bash, I know, df, ls, etc. In my case, have been provided by the GNU project, and they have multiple ways of operating. There's an environment variable that makes those executables be more conforming to the POSIX standards. Some executables have a command line parameter to be more conforming to the POSIX standards. There's possibilities of telling those executables to accept only command line parameters that are defined in the POSIX standards. Where the difference comes from, why are these POSIX conformance environment variables and command line parameters needed? Because the GNU executables, as far as I know, try to respect the POSIX standard as much as possible, but then they also go past that and implement additional command line parameters and additional features and additional regular expression domain-specific languages. So whatever we're using in the command lines that we have shown until here, most of them conform to the POSIX standards, will be available from multiple implementations of ls and sh, etc., and awk and sed. But sometimes, to be extremely sure that, for instance, your shell script is as portable as possible, you might want to enforce the POSIX conforming environment as much as possible. So instead of using bash, you can use sh, which is the POSIX shell. Instead of using, you should not use bashisms, which is bash extensions that do not exist in POSIX shell. Don't use gawk extensions that exist in GNU awk, do not exist in the POSIX awk, etc. And forcing POSIX conformance as much as possible will also will be like a linter for your shell script. If your shell script works, if you have enabled the POSIX conformance as much as possible, that shell script has better chances of running correctly out of the box without any additional changes on multiple other operating systems such as OpenBSD, NetBSD, FreeBSD, etc. macOS, and on different versions on different Linux operating systems, and maybe also on BusyBox. Correct command to show disk space usage. Disk free. DU, disk usage. There's no reason to use DU except for computing the correct size of a directory, because directory might have 3 files inside, might have 2 directories inside, those directories might have other directories inside, etc. So recursively computing the size of a directory is not fast and not easy to perform. You need to also consider hard links, symlinks, mount points, and many other possibilities, loop devices. Hopefully DU actually does what I hope it does. So 64K for the current directory, out of which directory 1 takes 12K, out of which directory 3 takes 4 and directory 2 takes 8. There's just 1K per directory. Because the files are mostly empty. Yeah, I do not know how to interpret this thing. But hopefully it computes correctly, recursively, the size of a directory. Otherwise, why would it be useful? Because ls space minus uppercase R already lists all of the directories recursively. Du minus sh. And for files. So it doesn't show files by default. Yeah, but fruits is just 5 lines, cannot. Not sure. So this shows the disk usage on the disk usage, how much space is needed on this disk to store the file, not the file size. So it's more about inodes and fragmentation and about sparse files, whatever, not about the actual size of the file. I'm not sure what this thing does, so I'll ignore. Estimate file space usage. Free command shows information about random access memory and about swap. So the numbers are like this. This is hardware random access memory minus video memory if you're using an iGPU, integrated general purpose, whatever, graphics unit. Swap, this is the sum of all of the swap partitions and swap files. How much of the swap is still not used? How much of the swap is used? Free has a -h command line parameter. So I have 32 gigabytes of random access memory, but then 2 are used as memory for the iGPU, video memory. Okay, we did -h. Continuously display memory usage at specified intervals. I'm not sure if free is part of the POSIX standard. I'm not sure if free -s is part of the standard. Okay. Continuously every 5 seconds. And then there's a third row that shows the sum of the previous two rows. Cool. Kill. Kill does two things. Actually stops processes in an ugly way with -n, or in general just sends Unix style signals to processes. There's a ton of signals. There's sig hop, sig user 1, sig user 2, sig interrupt, and one that's called sig kill. -n. Sends a signal to a process ID if you're using kill, or if you're using kill all, to a process name. I'm not sure exactly how matching is. Exact, ignore case, regular expression for the name of the process. So for instance, you can kill OBS either by providing the process ID 52465 or using kill all and parameter OBS. Okay, there is a list of signals. So man kill. We can see the manual of the process kill, of the executable kill. So some of the signals are hop, interrupt, kill, stop, continue. You can specify kill either using -9 or -kill or -kill. There's also signal 0. And the signals are available in here in the signal 7 man page. Let's look there. Standard signals. POSIX real-time signals and POSIX reliable signals. Terminate, stop, continue. There's a list somewhere. It's an enum. Sig FPE, sig seg. So this is the segmentation fault. Floating point error, sig FPE. Sig seg segmentation fault. This is about dereferencing memory that is not actually a pointer. Floating point error, that's, I know, division by 0. Standard signals. Okay, here's the table. Wow, there's hundreds of them. Signal abort, alarm, bus, child, continue, info, interrupt, input output, input output trap. Sig abort. System v polling. Wow. But the usual ways of killing a process, you go ps-aux, get the process ID of the process, this guy, and then you go kill -9 and you paste the process ID. Or you go kill all -9 and then the name of the process. 99% of cases you're using kill -9 and then the process ID because you want to kill just one process and all of its children. But sometimes just killing a process with maybe 1000 kids is not enough. You want to kill more, and maybe there's 10 different processes, I know 10 web browsers running under different users on the same computer. For instance, you want to kill all of the processes spawned by Firefox. So in that case, you would use kill all -9 Firefox. But again, the Linux operating system is a multi-user operating system. You might be on a massive server with thousands of users connected to that server. Be very careful which processes you're stopping. If you go kill all -9 and then the name of the web browser in there, you would create a ton of damage because again, many users connected to the same server, many users are probably using the web browser. Why would you use a desktop computer if you're not using web browsers? And people are doing important job in their web browsers. They're working in Google Docs. They don't have their emails that they're composing maybe are not backed up, so you're going to cause a ton of bad consequences. So kill all is useful when you cannot survive, where there's too many invocations of kill -9 that you must do, but you should default to using kill -9 and providing just one process ID. Very useful is PS3 that shows the tree of processes. So if you want to kill all of all of these processes, instead of going kill all these, kill all these, kill -9 this, that, it's just easier to kill the parent process. That will kill everything else, all of its children, by default on Linux at least. Okay, kill -9 the process name, kill -l. Okay, so -9 is the kill, but you can go -57 if you want. Or -s and then the name of the enum. Okay. Forcefully terminate a process with process ID 1234. Next. Uptime. Okay, so a useful tool to have if your computer is actually a server. You want to know when it was last rebooted. And if you're actually running an important production server, you probably want to minimize the number of reboots that you do across the year. People have seen computers that have 10 years uptime. That's very extreme. Of course, nobody has installed security updates in 10 years if your uptime is 10 years. But the so-called enterprise Linux operating systems, Red Hat Enterprise Linux, SUSE Linux Enterprise, have some patching technologies which allows your system to install the latest updates, even kernel updates, and then maybe you can apply all of those updates correctly without restarting your computer using special Linux kernel technology to refresh all of the processes and also the kernel mode without doing a reboot. And also you want probably to not kill all of your HTTPS connections or SSH connections while you're doing that. So those connections will die when they want, but the rest of the system will use the new bits, the new files that came via updates. I haven't used such a technology, so I don't know what the possibilities are. Okay, so in this case, it says that this is the current date time, 1752, up for 18 hours. Okay. Ping. Wow, ping. Okay. What we did up until now was file systems. Then we did file content with sed and grep and head and tail, and then we did process management with PSAUX, kill -9, PS3. Now we do networking troubleshooting. So networking means that your computer is connected to the internet, probably, or that your computer is connected in a local area network with other computers. Maybe your computer is connected via wireless. That looks like this. Your computer has what are called network interface cards. There's one that's called the local loopback device. That's another one that I'm currently connected via, which is the network interface card that's Ethernet and has an Ethernet cable plugged into my computer. Then there's a wireless connection. There's a wireless network interface card. And then there are additional network interface cards for very dedicated purposes for, I don't know, for virtualization software, for VPN software, or virtual network interfaces, etc. Okay. What you want is for your network interface cards that are of type hardware to be supported by the operating system, so 1 and 2. There are network interface cards which are software type, so are not of type hardware, so they're supported by the operating system because they're invented by the operating system, like these two. But these two actually are actual hardware that you can put your hand on, and they need the correct kernel mode driver, and they need to be discovered at computer start time or when the operating system was installed, and the correct kernel module driver should run. They should be configured correctly. The configurations are for IPv4 and IPv6, different configurations. A configuration means, for instance, for IPv4, there's a IPv4 address for the network interface card, a net mask, a broadcast address, and a gateway address. Additional to this, there's the network interface card might be served by a DNS server, might be served by a DHCP server. The network interface on this system, on Linux, has a name, so enp8s0 or this guy. These are actual files that exist in the /dev directory. This is there, this is there, this is there, this is there. Okay. Once you have all of these configured correctly, you can go to the next step, which is your computer can communicate to your gateway. So let's look at my configuration. This is Ethernet network interface card. This is the IPv4 address. This is the CIDR. This is the broadcast address. And the address of the gateway probably ends with 1, so let's ping that. I should be able to ping myself. I should be able to ping the gateway. I shouldn't be able to ping the broadcast address. Okay. Which means that my computer is correctly connected to the gateway. In my case, that's a wireless router that's provided by my internet service provider ISP. If the ISP has configured correctly the wireless router, and if I have paid my subscription to the ISP in time, then probably I have access to the internet. And I can see that I have because I have pinged google.com and it worked correctly. Okay, what pinging does, a connection will be created between me and google.com that looks like this. So my computer, which is 192.168.101.36, has connected to the gateway, which is the same IP address but ending with 1. And then that has connected to this computer, to that computer, to that computer, etc., until it got to google.com, which is probably this one, 142.250.180.206. And this is being done using the protocol ICMP, which is not TCP, not UDP, is something else, the ICMP protocol. Okay. By default, ping keeps sending forever. What you should look at, so by default it says ping this, so this line, because I could resolve, or the computer could resolve google.com to IPv4 address. So we did a DNS query where it says the host name google.com to which IPv4 address it corresponds. And the DNS server replied that 142, etc. .206. And then my computer tried to connect to this computer, ending with 206, using the protocol ICMP, and it succeeded each time. Let's see how it succeeded. It succeeded at sequence 1, 2, 3, 4, 5. So you should look for having the reply. Sometimes you don't have any replies, which means DNS works, but networking doesn't work. Sometimes you receive a reply, but then the times are awful, like 1000 millisecond. That means you're probably on Wi-Fi, maybe you have firewall issues, maybe your internet service provider is doing something interesting to you. So that these times should be way below 1000 milliseconds. And then you also want to have all of the sequences, not skip anything. So sequence 1, 2, 3, all of the numbers should be here. Sometimes you get sequence 1 and then nothing for a while, and then it says ICMP sequence 9. All of these lines are missing. So that means that your computer tried to communicate using 9 sequences to google.com, and maybe google.com has received 4 out of these, but then back to you only 2 came, the first sequence and the 9th sequence. So that's a very bad internet connection with a ton of losses, which means that the TCP protocol will probably work, but there will be a ton of retries and the network speed will be really bad. Web pages will load incorrectly, will time out, you will need to refresh your web browsers. Okay. Pinging works forever, you need to kill the process from time to time, so Ctrl C. If you want to only send 4 packages to google.com, you go like this probably. You will see only sequences 1, 2, 3, 4, and then the ping process will finish and you'll be back at the bash prompt. Okay, we did that, -C4. %, packet loss. 4 received, 4 transmitted. So these sequences are packets, ICMP packets. Each packet is 64 bytes. TTL 117. The TTL will be different between different versions of Windows, different versions of Linux. I'm not exactly sure how this thing is computed, but there's a significance behind the TTL. Okay. Waiting for a number of seconds is useful if you want, for instance, to sleep. For instance, you want your computer to sleep 1 second and you don't find any other way to sleep the computer, to make the computer not do anything, whatever, to make bash not do anything for a second. You can go -I1. Maximum number of hops a packet can take before being discarded. And the number of hops was, as seen from trace route, was, I don't know, less than 20. Okay. Ping. Curl command. So there's a pair of commands. One is called wget, and the other one is called curl. They're kind of similar. Whenever possible, I use wget because I only download things. Let's download, for instance, this file. So it said that in the current directory, /work/1 has created a file, bash_curl.php, where it has put in the content of this file 300 kilobytes. Let's see how the file looks like. It's this thing, the initial source code of the file bash_curl.php, of the web page that we're looking at. Source code in the sense of machine readable format of the web page, not the human readable version of the page. Okay, so this was having a URL and downloading that URL locally. The same thing you can do with curl, but the incantation is a bit more complicated, in the sense that I don't really know how to do this with curl. But I can figure out. So curl, and then fail help output remote show silent upload user verbose version. Help all without minus minus. Okay, and then this thing I put it in a plain text file. And I want redirects. Uppercase L, okay. So curl URL and it looks okay. Maybe there's no redirects in there. Okay, and how do we write the output to a text file? -o output. So -- output and then the file name, which is strange because curl already knows the name of the file. Directory to save files in. Okay. Looks okay. Curl URL, if it manages to find the file because of HTTPS redirects, will write to standard output the content of the file. -0. Wow. Or -uppercase O. Okay. This is the most important command line parameter, -L follow redirects. -uppercase O, L. Instead of displaying the body, you can display the reply, HTTPS reply headers. Let's see, that sounds interesting. The HTTP header key value pairs separated by colon, and the key, so the name of the value, is case insensitive. There's date with the uppercase D and date with lowercase d. Okay, and this is how to download a URL, so a file which contains the source code of the URL for HTTPS web pages, but then curl is also being used for writing to HTTPS, not just to read from HTTPS. So writing in the sense of by default it does HTTP verb get, but it can also do HTTP verb head, which is probably what we just did with curl -i. Then you can go HTTP verb post and probably the webdav verb put, etc. You can specify user and password if the HTTPS server requires a user password to access the URL. Which command retrieves the web page curl? We just used wget. Download directories recursively, so it knows how to download an entire directory. Wow, let's see what it does. So make dir2 cd2 and let's download this entire directory. I'm not sure what it does. And I should totally stop this thing. This is a text user interface file manager. It's called Midnight Commander, another GNU project. So in here, wow, it downloaded all of the files that it could from all of the URLs of the website, not just from under /bash. Yeah. Sounds like a bug. We should have specified a slash. No, it doesn't matter. Okay. If the file isn't downloaded correctly, you can resume the download. This was an extremely useful flag back in the day when download speeds were 14 kilobytes per second and you needed to download maybe a 70 megabyte installer. It might be that wget-r works correctly if your web server is actually serving a directory listing, it's not just a static website. Okay, let's clean up. Control L, CD to the parent directory dot dot. Remove the directory to ls. Using the SSH command, you can connect to a remote machine or you can connect to the local machine. How do you do that? You need to have on the other machine or on the local machine install the SSH server. SSH server 99% of cases means the open SSH server, including on other BSD operating systems, including on Mac OS, on Windows, etc. There's an alternative that's called Dropbear SSH. But the SSH server is probably going to be OpenSSH. And then as SSH client, you're also probably using the SSH executable from the OpenSSH project. So let's see how we do that. SSH, and then username, and then where. Let's see if the SSH server listens to localhost. So it's connecting via IPv6. Asks for the password. And that's it, we're connected. Okay. For security reasons, the default port on which the OpenSSH SSH server listens is TCP/22. But for security reasons, you might make the OpenSSH server listen on a different TCP port, such as 2022 or 2222. And then all of the people that want to connect to that SSH server need to specify the port that's the non-default port. So in this case, I connected without specifying the port because the SSH server is installed on the default port, which is TCP/22. But if my port where the TCP port where the OpenSSH server listens is 2222, then I would have used the command line like SSH and then -p and then the port and then the rest of the SSH command line. I'm not sure what -C is. Hopefully compression or whatever performance things can exist are enabled by default. Identity file. Okay, so -v is for debugging purposes. You probably want to connect first without -C, but in verbose mode. So you want to connect probably SSH -v. Write the standard output to a file. You can copy paste from a terminal. I go copy. And then do the same thing, but with -C and v. And see if different output is being shown, like the first will say not enabling compression and the second one will say enabling compression. And if that's the case, indeed transfer speeds might increase even dramatically if the compression is really fast. Control C. This was back in the time when the X11 server used to exist. There's always better ways of doing than using X11 forwarding. You can tunnel VNC protocol via the SSH protocol. Okay, SSH. SCP is a companion of the SSH command. So SSH is an executable from the OpenSSH project that allows you to connect in terminal mode to a remote computer, such that you can run bash on a remote computer, but it looks like you're running it on the current computer. Just I'm not even sure what changes. Yeah, you're on a different operating system, different IPv4 address, different current directory, maybe connected with a different user. Everything's different, but still console behaves, the graphical user interface terminal behaves in very, very similar ways. You can still resize it, you can still copy paste text. You can still have access to hundreds of Unix style executables, to a Unix style shell, etc. Whereas SCP is a command that allows you to move files and directories from the local machine towards the remote machine or vice versa. And the syntax is similar to CP. So CP is copying files. You give it a source and a destination. And SCP is copy over SSH tunnel and the same source file parameter. And then the destination directory in this case uses a special SSH syntax where it says who at what computer colon and then the path where you want the file to be put or the directory to be copied. So in our example, we could do something like there's this file that we have just downloaded, bash_curl.php. We can copy it to a remote computer, username, where, so the computer name, colon, where, asks for the password, says SSH password of the user N, and it says that the file has been copied. And we can also see the file in the home directory. It's in my home directory with the exact same name. The most important command line parameter is the port. Unfortunately, it's not minus lowercase p, the same as for SSH, but it's minus uppercase p. You can copy entire directories, similar to CP. If you want to copy two directories, you're using the CP command line, you're also using the command line parameter minus lowercase r. Okay. SCP. rsync is similar to SCP minus r, but is the most often used command when you're copying files remotely to other machines. Other machines meaning over SSH, over the network file system NFS, and probably also towards AWS S3, if I remember correctly. The advantages of rsync: it does the things correctly. So I don't know, it checks the files, it does differences between files only sends in the delta, is faster, the number of bytes transferred over the network is smaller. I know. A bunch of smart people have written their license thesis and master thesis on how to improve rsync. So It's the thing that you would use to copy a ton of files remotely. But by default, what it does, how you usually use it, you have two directories, a local one and a destination one, maybe on the same computer, maybe on a USB drive, maybe on a remote computer. And from time to time, you're copying your entire home directory with some exceptions to that destination directory. So you probably have a long rsync command line invocation, and you're running it each week, for instance. And by default, rsync will take the differences, so the files that have changed on the current computer, and make sure the remote files are identical. The files that have been added to the current computer will put them into the destination directory, but then it will not delete the files that have been deleted in the source directory. This is a command line parameter to also delete in the destination directory the files that have been deleted in the source directory, but that's not a default option. The -- delete command line parameter is the one that will delete from the destination directory the files that have been deleted in the source directory. Archive mode preserves permissions, M times, C times, symbolic links, etc. You always copy recursively using rsync. You always use A to preserve as many of the metadata about the file as possible, elements. Okay. Zip command. This is one of the commands that probably is not defined in the POSIX standard and probably is not available on many of the environments where you have bash installed. It's actually a compressor, so or an uncompressor. It's a compressor. There's a zip and unzip. Okay. Does zip know how to compress? Yes. Does zip know how to uncompress, decompress? As far as I know, that's not the case. So it's probably the same program, but then split into two executables. There's zip and unzip. They're a pair. pk zip, pk unzip. When you're compressing files, there's a ton of compression algorithms. There's gzip, there's bzip2, there's zip, there's lza, there's 7zip, there's the macOS 9 thing. I don't know, deflate, or what was the name of the thing? Compress. There's deflate, there's compress, there's uppercase Z. What else? Z standard. Many compression algorithms. I actually compress using tar, not using zip. I'm not really using the zip format. But zip format is useful for interoperability if you want to send the file to somebody from macOS or using Windows or using Linux. There's bigger chances that they will have a decompressor for the zip file format. Okay, so let's see what it says. So zip, archive name, and the files to be added to the archive. Or you can provide a directory. Zip file and then a list of files. Recursively zip a directory. Okay, but -r, as far as I know, doesn't do what you want, which is it will, when you want to compress the content of a directory, you don't really care about the name of the directory. So you actually want inside the zip archive to have file 1, file 2, subfolder, subfolder. You don't want to have a single top level directory inside the zip, which is called folder, and in there's the other files. Advanced features are encryption, of course, and maybe splitting the resulting archive into more pieces. Okay, unzip is the reverse. You just go unzip and then the name of the zip file, and it will inflate in the current directory. You can specify the directory where to deflate the files, -d. Okay. Extract zip. I usually extract files using 7-zip from zip files. tar. Okay, so tar is similar to zip with a twist. It's that there's not one file, but there's two files. So first of all, you take many files, the source files, and you create a tarball file that's not compressed at all. It's just the files, the source files are being grouped together in a single destination file. And then you take that file, the destination file, the file with extension tar, that's not compressed, and you compress it. Again, there's, I don't know, at least 20 compression algorithms that can be applied to tar files, and they're all known by the command line tar. So tar knows how to do both things. Take many files, create an uncompressed .tar file, take a tar file, create a compressed tar file, take a ton of source files, create a compressed tar file, or create a tar file extracted, or create a compressed tar file and extract it. Depending if you provide -c or -x. So -c creates and -x extracts. You almost always use -v and -f. -x doesn't mean zip, it means just compress the thing. So if you want to extract a file that has the extension .tar.bz2, for instance, you would go tar minus and then x to extract, vf, and that's it. It will compute the type of compression automatically. It will determine its bzip2 and it will decompress it from bzip2 to a not compressed tarball and then extract that thing. When you create, instead, you need to specify the compression algorithm that you want. So if you go cvf, as in this case, which is create and verbose file, it will create a not compressed tarball. Okay, if you want to compress it, the options are lowercase z means gzip, GNU-zip. And there are other, lowercase j is busy too, uppercase j is something else. So the encryption, the compression algorithm to be used is specified using a command line parameter. When you create, there's no need to specify it when you extract. Create a new archive, C. Okay, and now we're at creating script files. When you're creating script files for Bash, there's two different steps. One is getting the command lines that you need. You're probably going to run a ton of command lines in Bash interactively. And then once the command line works correctly for you, you're just going to copy the command line towards the file that's the Bash script. So step one is knowing how to compose Unix command lines, Bash command lines, to know about as many Unix command lines as commands as possible, to know what they can, what are their abilities, to search on the internet for correct command lines using those executables, copy the command lines to a plaintext file, but then there's a second part which is knowing things which are specific to Bash scripts. And in here, you should know how to put a shebang at the start of the file. You should know how to comment out lines, how to create multi-line here docs, docstrings, comments, how to create sub-algorithms, so functions. Maybe you're using labels, how to use alternative structures, repetitive structures, so similar things that you would do in a programming language. You need to know how to create one line of programming language that's valid. For instance, you declare a variable and assign it a value too. But then you also need to know how to group programming language lines into functions, procedures, methods, classes, objects, static methods, packages, DLLs. So there's two different parts of at Bash scripting also. The lines that start with a hash sign will be ignored. Each line will be executed in order. There's exceptions. You can have really long command lines that use end-end separator or semicolon separator. You can use labels to jump around the source code. There's repetitive structures which will jump from line 9, which is the last in the body of the repetitive structure, to line 7, which is the first one in the body of the repetitive structure. Okay. So let's see. So it uses semicolon to have two different command lines on the same command line. If the first command line fails, the second will also be run. There are variables. We didn't really use variables yet. We only looked at the environment variable home. There are many more environment variables. These. Variable names should be, of course, meaningful because we're actually programming. We're not just writing some things that cannot be maintained. Start the comment, this guy. Okay, the shebang is always the same thing, always the same, I don't know how many characters, 10 or something. Let's actually count them. One. So pound exclamation point slash bin slash bash. Doesn't matter if bash is installed in slash usr slash bin or in slash usr slash local slash bin. So let's create our first script. First of all, I'm going to create a different directory. Go there and create a file hello.sh, and I'm going to see if I can do the editing and debugging and running in Visual Studio Code. So I have opened the directory 2 in Visual Studio Code. There's an empty file here, hello.sh. It says that the file should have this content. We'll put a trailing new line, so line 4 is just empty. I'm going to save. And if possible, I would like to use a debugger inside Visual Studio Code. So let's see if that's possible. Extensions, Ctrl-Shift-X, search for bash, and the first result here called bash debug from Rogalmic. Install. I trust. And let's see how it works. Simple debugging. Yeah, hopefully we'll figure something out. So we probably can put a breakpoint on line 3. And let's run this thing. Bash debug. I'm not sure where the output should be visible. Debug add configuration. Bash DB is the backend and is part of the package. Select debug add configuration. Where is that? Create launch.json. Okay. And step over F10. Continue, finish. Okay, so hopefully that's all that's needed. So let's see, we have this example. It prints hello world to the terminal. This is a comment, and this is a line that's really special. It is a comment, but it's also a shebang, which means that if we make this file executable and we try to run this file using, for instance, ./hello.sh, the system will try to figure out if this file is a plaintext file. It is. It will try to find out what executable should be used to run this executable plaintext file, and it discovers from the first line that that should be bash. So it's probably going to start bash with this file as command line parameter. We can actually see that. Let's go further along. Says that we should learn how to use variables. How do we do that? Let's create a second file. Put a breakpoint on the first line that's not a comment, so line 3. And simple debug. It shows two variables, $PWD and $question mark. I'm not sure why. There's a call stack. Because of the extension that we have, the bash db extension. Okay. Next up, let's increase the font size. More. Okay, let's step over F10. And now we should have a local variable named name. If I hover on top of the variable name, it says this thing declares space minus minus name equal world. And if I'm looking at $name, it looks inside the value of the variable, which is just the bash string world. Cool. Okay. So this is how we declare variables. You don't need to specify the type. This is how we do the first initialization of the variable with the literal string world. And then this is how we read from the variable $, and then the name of the variable. Next. So this is the definition, declaration, initialization, and this is how we read the variable, the value that's stored inside the variable. Okay, variables can have different types. There's a string, there's a number. Let's create another file. Don't forget about the shebang. Trailing new line. Breakpoint on the first non-comment line, line 3. Debugger, run and debug, Ctrl-Shift-D. Start the debugger. We can see the exit status from executing the previous line. So it says that echo was successful, exit status 0. Number equals 42, exit status 0. Okay, so name is a variable, number is a variable, number is actually a string. Cool. So both name and number are local variables of type string. Okay. And then we read the values using $name and $number. And it just works. The number is 42. Okay, so these are variables that we declare inside the script. There are also environment variables. There are variables that pre-exist even at the first line in your script, which is the shebang, such as $path. Okay, so this is the value. It's tilde slash dot local slash bin slash usr slash local slash sbin, etc. F10, your path is, and then the rest is the string that's stored inside this variable. Local versus global variables. In Bash, you can have functions, so sub-algorithms. You can define them. They have a signature. They have a body. They can be called. Okay, so global variables, you probably declare them outside blocks such as function bodies, and then local variables are available inside the scope of the block. We'll see. Let's see this function first. What did I do? Breakpoint and debug. So the first line doesn't do anything because it's a comment. Line 2 is white space. Line 3 doesn't do anything. The same for the rest of the lines. And then the first line that's actually executed is line 7, my function. Next up, step into F11. Now line 3 is evaluated. Now line 4, there's this keyword local. So maybe local is used to define that the scope of local var is just inside this block of code. So local var does not exist yet. We did not execute line 4 yet. F10. Now local var is a variable, again of type string with content string. The value inside the variable is IAMLocal. And we print the value. And we should see that the value is not defined on line 8. Let's prove that. So line 7, then line 8, and there was nothing to print because this variable does not actually exist. Okay, so maybe this is the one, the keyword local. String operations, combine strings using variables concatenation, and arithmetic using variables. Let's see that. We already saw string interpolation, or what the name of the thing is, where bash finds a string surrounded with double quotes and then expands all of the $ variable names that it can. Even if the variable is not defined, it's going to expand it to the empty string probably. Okay. Variables operations.sh shebang. So let's see with the debugger what's happening here. A global variable is being declared inside this function, inside this file. Another global variable, both are of type string. And then bash is going to expand $ variable name. If we want bash to not expand, we can use single quotes. The syntax highlighting inside the code shows that this $ is going to be a actual $, because all of the characters in this string have the exact same color. Okay, so no expansion of $ variable name has happened. This is the way the syntax highlighting shows. This is the $ variable name. This will be expanded. and then this is a string, will not be expanded, and then this is $, another variable name, and it will also be expanded. Let's see what happens. So num is a variable, global, value 5 string, num value 10 string, and then somehow using this syntax, sum is a local variable. It's also a executable slash usr/bin/sum. But because there's an equal here, the /usr/bin/sum executable will not be started. Okay, so this is probably the syntax that converts num from string to int, the same for num2, and then computes the numeric sum, and then that is going to be converted to string and stored inside the global variable sum. Probably. So sum is a global variable of type string, value the string's 15. Okay. If that's true, it means that we can declare num1 like this and still get the same results. Okay, so num1 is exactly the same as before, a string with the string 5 inside, string with a string 10 inside. Sum should be 15, and it is. Yeah, probably that's the way Bash works. So all variables are of type string. But then you have special syntax to convert temporarily the string to a number such that you can perform numeric operations such as integer plus integer. Next up, Bash data types strings. Numbers in Bash can be used for arithmetic operations. Bash supports integer arithmetic, addition, subtraction, multiplication, and division with the exact same syntax, $, round parentheses twice, and then close the round parentheses twice. We actually saw all of these. Strings are sequences of characters used to store text. They can be manipulated using string operations such as concatenation and substring extraction. Okay, no need to run any of these because we already have everything in here. So this part is actually this part. Yeah, let's do it. Okay. More variable operations. Okay, so now it became a global variable, another global variable full greeting, which we write to the standard output successfully. It says in here success, this 0. Okay, it does not matter if you declare num1 as a string or as a integer, it's still a string. Sum, we saw the syntax previously. Difference 5, product 50, and quotient 2. And write everything. Erase. Okay, let's see erase. So we have this global variable that's defined using round parentheses, and then there are 3 strings inside, literal strings. There's a bash for repetitive structure, for in, it's a for each, do, echo, and then done. Fruit in fruits, and then what is this? Let's actually run with the debugger. Okay. So fruits is declared as an array position 0 apple string, position 1 banana string, position 2 the string cherry. So bash does really know arrays. Array is a native type in bash. And the scalar string variable type is also native. Okay, so this is probably the iterator integer variable. So the counter variable goes from 0 to 2. And then it goes fruits of 0, and it's apple. Uses this syntax, $, and curly brackets. Okay, so this is one variable, which is maybe local to the body of the for. Let's actually see. So fruits is an array. Fruit does not exist yet. Fruit is now a string with a value apple, which we can print. Cherry, and then okay, so let's see what fruit is. Fruit is still a cherry. Okay, so this fruit, which is the local variable of the for each, is actually a global variable. And then this is the integer counter that contains the current index inside the fruits array at each iteration. Okay, associative arrays in the sense of dictionaries and maps and hash maps. Okay, so now we see why it says declare when you hover on top of a variable. It says declare minus a fruits, so it declares fruits as an array or map, whereas fruit is declared as minus minus. So declare minus a versus declare minus minus. Then the variable name, and then equals. So minus minus being a scalar and minus a being a minus lowercase a being an array and minus uppercase a being a associative array, so a map, probably. So arrays have index of type int starting from 0, so the index 0, index 1, index 2, and values these three strings, whereas associative arrays or dictionaries or maps have as index a thing, a string. Okay, this being a string. Let's see. Color still does not exist even though it has been declared on line 4. Or maybe just the debugger doesn't know how to explain when you hover on top of colors what colors is. Apple is the string apple. So what it did here, it declares a dictionary with 3 position. First position index named apple and so whatever the key named apple and the value named the value red. Key the string banana, value the string yellow, and the third one key named the string grape and the value the string purple. Then this second element is being removed, unset colors banana. Let's see what happens if we try to print the value of banana. I cannot say. Either the element colors of banana has disappeared altogether, or just this value has become the empty string. Or maybe you can put anything you want in here. Yes, you can put anything and it will see that there's no value stored in colors for the key test. And it will print the empty string. With followed by a new line because we're using echo. Okay, it says that Bash doesn't support floating point arithmetic, so numbers with a dot, and you can use BC or awk for such a thing. There's other possibilities, there's other programming languages, there's Perl, there's C, there's Python, etc. Roots, the first element is 0. Bash operators. Comparison equals, not equals, less than or equal, greater than or equal. Comparison. String comparison, equal, not equal, less than in ASCII table order, greater than in ASCII table order. These are what? Numeric, and these are strings. Addition, subtraction, multiplication, division, modulus. Okay. Logical operators and or not. File exists, directory exists. Is it a file? Is it a non-empty file? Okay, so let's start these. The alternative statement if else in bash. So declare minus minus, declare minus minus. Okay. And then we need to decide what we want to do. So we want to compare with 10, but with the string 10, with the number 10. For number comparison, there's minus GT. For string comparison, there's less than. So for instance, num less than 15, then minus GT, then 10. Okay. So it's going to enter the then block. The next line to be executed after line 5 is going to be line 10. Line 6. Where is it? So line 4, 5, 6, and that's it. Okay, and the other type of comparison is if 15 is an integer, is a string, is greater than what? I have no clue what I'm doing right now. Let's see how that works. So 15 is greater than a. The ASCII value for uppercase A is, I don't know, 40. And 15 is also a string. Let's actually look that up. I searched for ASCII table and it's asciitable.com. So uppercase A is decimal 65 and the string 15 is 49 and 53. So 4953 is greater than 65. Next up, a alternative block, a alternative structure if with the else block. Similar to what we had before. This part existed before, and now we also have the else block. So instead of ending if then and then fi, there's this else and the block of else before the final fi. Fi being the inverse of if. So if 8 is not greater than 10, so line 8 will be executed as the else block. Number is 10 or less. Elif. Elif is similar to other programming languages where you have if, else, and then if, else, and if, else, and if. So instead of embedding another if inside the else block, you're putting a ton of blocks at the top level. So a block at the top level, another block at the top level, another block. But you could just use simple if else p structures, but embedded one in each other to obtain the same result as using elif. I actually do use elif. I find it easy to read. And when I use elif, I probably have all of the happy path in else, not in the if elif blocks. So if and elif, I use them just to peel out the not happy paths, but very precise ones, like this number is not positive, this number is not greater than 1, and then only if all of the validations possible in the blocks above, only in else I run the actual thing that I wanted to run after I pass the validations. So the happy path. Okay, it's exactly similar to what happened above, but there's this else being replaced with an elif. Nested if statements work as expected. No extra syntax is needed. Okay. So it validates if it's greater than 0 but less than 10. Then the happy path is in the then block. Loops, repetitive structures, for, while, until, for each, everything is available here. Okay, so this is a syntax that's similar to Pascal. For variable name in, and then you provide a set using dot dot. Okay, so let's see what happens. We have no global variables yet. This entire line except the do was executed, so everything until the semicolon has been executed as a command. And now we have a global variable that doesn't have a value. Iteration 1, 2, 3. And I is a scalar. Cool. Okay. And there's the loop while ends with done, for ends with done. The block starts with do, ends with done, and there's a semicolon between the first command, the for, or the while, and then there's a separator semicolon, and then there's a block. Block starts with do, ends with done. And there's post increment operator. Wow. Cool. So a global variable named count, which is of type string. And then this line until semicolon is being executed. Oh, there's this block being executed. So this block has been executed. Which returns 0, which means success, which means that $n count is less than or equal to 5, which is 1. So 1 is less than or equal to 5. Count equals 1 was executed. The condition has been executed. Return success. So the body of the while is going to be executed once. The debugger is not that perfect, but execution works correctly. Okay. Now count is 2. So although count is of type string, it's still incremented because there's 2 pairs of round parentheses, which I know does conversion from string to integer, then post increment, then conversion back to string. Okay. And the condition is still has still returned true, which is 0, which is success, exit status. 2 less than or equal to 5. Print. Count is now 3, 4, and now it's 5, but the condition is still true, is less than or equal to 5. Okay. Now count becomes 6. Okay, let's see that it's 6. And now the condition should return, I know, 1. We can see it. Let's see the exit status of this thing become non-zero. It's still 0. Okay. Okay, next up, until. So this is actually a command. This is actually a command, and then a semicolon, and then a block. The syntax for the block is identical for all repetitive structures, while, until, or. It's just the first part before the semicolon that differs. Until keyword, while keyword, and for keyword. And until is just a special case of while. We'll skip this one. Okay, then break and continue. I use break a lot. I'm not sure I have ever used continue. So break means that, for instance, here when it reaches this block, if the value stored in I is equal to 4, then it will break, which means it will exit from the enclosing repetitive structure. The enclosing repetitive structure of this if is this 4. So the line that's after this done will be executed next. Okay, so this is a valid block, this is a valid block, and then there's two 4s, one in another. Variable names I and j. Everything sounds as expected. For I in. There's other syntaxes for the for structure. There's one with variable initialization, incrementation, and verification condition, and then there's in, for instance, sequence. Sequence seq being the executable from /usr/bin/seq. Okay, a function. We have declared the function, we have called the function. More function features. This is the way you pass function parameters or arguments. $1, and then when you call the function, you pass it the value for the first parameter. And then there's also return values. Which is done how? By using echo. I'm not sure. Echo doesn't write to standard output, instead it writes to the return value. I would probably use return if they're completely equivalent, echo and return. Let's see these. So that's function with parameters. So all of the declarations of the functions are being ignored when bash executes. So it got to the call of the function greet with parameter Alice. And now the function block is being executed, starting with line 3, not with line 4. Declares local variable named name, and using the $sign and then an integer variable, it I have pressed F11 to step into local keyword, a scalar, declare minus minus, echo works okay, and that's it. Let's see this function with return value. So a function that returns the sum of the two arguments parameters, the first one and the second one. Let's see if instead of echo actually return works okay. Let's run it without any breakpoints. The sum is nothing. The sum is 8. So I cannot prove that return works. I can prove that echo does work. So echo seems to work. Return probably exits out of the script or something. So this text is wrong, or the return should be deleted. Using echo statement is okay. A very strange keyword, echo. So in here it's the way to write to standard output, the parameter of echo and then a \n, whereas in here it's the way to return values from functions. Let's see how that works. Let's have breakpoints everywhere. So add is actually a function. It's going first to call this part. F11 step into. So says that this entire line has been executed, evaluated to 0. Success. Add 5 and 3. This thing is evaluated. Okay, let's see the value of sum. It's the string 8. And then this echo, because it's inside the function, will not write to the standard output. The debugger here doesn't know how to inspect the result, this variable, but it works okay. The way to define a function, the name of the function, and then a pair of parentheses. This is the way to define functions that's available in Bash, but also available in SH, because Bash has also additional syntax for defining functions that's not portable to the POSIX style Bash, but the POSIX style shell SH. So we did an array elements, read with $, with this long syntax, write to the value inside a array element with round parentheses. And then that's it. We're back to the first step. So this cron thing is the last page of the tutorial from W3 Schools, the bash tutorial. Cron and cron tab. Cron command used to manage, and cron is a background service. Cron tab command. Wow. I have never used this, and I'm not sure how portable this thing is in the Linux systemd world. There's a domain specific language, DSL, that looks like this. Zero zero means minute 0, hour 0, so runs each day at midnight. Then there's day of month, month, and day of week. Let's see if I have such a thing. Yeah, it's probably defined in the POSIX standards. Therefore, all systems do support them, but they are actually implemented using something else, using systemd in the case of Linux. Okay, so that's it. We finished the bash tutorial from W3 Schools. This is it. Thank you.